Hey guys, Pankaj here. Welcome back to my YouTube channel. So by now we have completed NumPy and Pandas video, and I think you will be very much familiar with like how NumPy and dimension array works, how Pandas data frame works, and what are various operation techniques, right? So now you'll be very excited to know like how to visualize the data once you have the raw data, correct? So today we are here to see data visualization using Matplotlib. Okay, so let me show my desktop and what and all I'm going to cover today. I'll show in the notebook. Okay, so here are the topics which I'm going to cover today in Matplotlib library. So for data visualization, believe me guys, Matplotlib is the best library so far in Python. And whatever other library also supports for data visualization, it has been derived from Matplotlib. So if you know how to use Matplotlib and all the support function, then you can easily work on any other advanced library. Okay, so after this, let's say we are going to talk about Seaborn, right? So which is also working on same principle and similar kind of functionality, whatever is supported by Matplotlib. Okay, so let's see what and all chart or plot I'm going to cover today. So we'll see basic plot like line, scatter, bubble, and bar chart with horizontal and vertical bar. How to plot stacked bar plot. Okay, how to put the label on the bar plot, and what is the technique for smoothing the line plot. Okay, how to plot histogram, pie, stem, lollipop, area plot, what is image plot, and what are various properties which we can modify in the plot. Also, we'll see how to draw horizontal or vertical line in the or inside the plot. Okay, how to write the text data in the middle of any plot, and subplotting and resizing plot size. And if time permits, then we'll see 3D plot as well as dual axis plot also today, or maybe in the next part of Matplotlib. Okay, so whenever you guys have any data or raw data, then first thing will come into picture or in your mind, like which kind of graph to be used for the given data. Okay, so I have already provided one difference link. This will be good for you guys to go through it. But yeah, whenever I plot something, then I'll tell you like you can use this plot for this kind of data. But to know more detail, I think I would suggest to visit this particular site and understand each and every plot, where exactly it is used, why to use, and how to plot them. All those things are explained properly here. Okay, so let's see the library, what and all I'm going to use. So I'm going to use NumPy as NP for creating the random data, and data frame in case you are going to plot with the feature wise or column wise in a given data frame. So we'll create a data frame based on NumPy random data. And matplotlib.pyplot is the library which we are going to use for plotting any data. Okay, so just remember this case sensitive matplotlib.pyplot as PLT. Okay, so let's see, code all the libraries. Let it load. Meanwhile, you can see here all the chart types are explained, when to use, where to use, what to avoid, what not to avoid. All the things are mentioned here. I think it is not loaded properly. Okay, so libraries are big, so it is taking some time. Okay, so it is loaded now. And after that, this line, I'll tell you why I'm using it, because right now we are using notebook, right? So in notebook, how you can create a plot within the notebook itself. So for that, you need to, mostly this is enabled by default, but in case some guys are, some of you are not able to see the graph in the notebook itself, then you need to run this magic command, that is matplotlib inline. Okay, so let me run this. Okay, and if you don't run this, then it will normally open a pop-up, and in that pop-up window, all the graphs will be there. You need to close it manually, then again generate a new graph, which doesn't look good if you are working on Jupyter Notebook. So better you enable this line, percentage matplotlib inline. So it is going to plot all the graphs in the notebook itself. Okay, so now let's quickly create a graph. So guys, before plotting any graph, let me just show you a couple of things. So for any graph, what do you want basically? Okay, so you need, let me just annotate here. Okay, so basically for two-dimensional plot, right, what you are going to have, you are going to have X and Y, right? So this is your X axis and this is your Y axis, correct? So all the points will be mentioned here. Okay, for given x point, what is my y value? So this is basically, this x-axis is known as your independent variable. Okay, and this y is nothing but dependent variable, which is depending on x. So in x, I have some value, let's say 2. Okay, then for another point, I have, let's say 4. Okay, for another point, let's say I have 5. Okay, so like that, all the x point given y points will be there. And later you just plot those points and draw a line. Okay, so in case you are plotting a line, you can draw a line. In case you are plotting a stem plot, you can draw a vertical line. Okay, if it is a bar graph, then you will just have all the x and y point, and here all the bars will be mentioned. Okay, for the given x and y point, and so on. If you are having pie chart, then you will have basically a circle, and from circle, all the points will be derived. Okay, so what is one particular slice, different slice? It's kind of pizza slice, which is nothing but your pie chart. Okay, similarly, if you're going to have scatter plot, then again, so here x and y point, and all the points will be scattered together along with axis. Okay, so if you see in all the graphs, there is one common thing, which is nothing but for x and y points. Okay, so x in the given x-axis, what are the point, and for given x point, what is your value of y? Okay, so very important thing, only you need to have x and y coordinates, or x point and y points. For corresponding x point, what is your y point? That is what we are going to plot. Okay, so let me clear the graph now and show you. Okay, so that is what I'm just creating one x point. So x point is basically from 1 to, let's say I'm going to have 50 points, and I'm going to generate 50 data points. Okay, so let's say from 0 to, or maybe 1, 2, 3, 4 up to 50. And what is my y value? So y value, let's have a random number between 1 to 50. Okay, between 1 to 100, I'm going to have, let's say 50 random values. Okay, similarly, I'm just going to have y2 also for later use. Okay, so now it is created. Okay, so if you want to see x, this is my x point. Print y1, this is your y2 point, and print y2 is your y2 point. Okay, all are random. Now let's plot it. So first thing is, let's say basic plot is line plot. Okay, so for that we have used Matplotlib plot, PyPlot as PLT. Okay, so PLT dot plot. Now, if you take a look at the help of this, right, what it needs a lot of argument. So guys, this is all Matplotlib library, right? So in that library, it's about a lot of parameters. So each parameter, if you want to see, let me open Matplotlib library. Yes. So Matplotlib org. Okay, so if you go to documentation part, where is user guide tutorial? Okay, so you click on any of the plot and you will show all kind of supported parameter for each and every plot, and what and all values can be supported, and what and all value you need to provide while plotting it. Okay, so this is the best documentation from Matplotlib org. Okay, so you can just refer it and just watch. So first probably you'll see what and all I'm going to show you. Then you click on that particular graph and see what other points are supported. Okay, so line plot. So if you are getting confused about all those parameters, the best thing is, as I mentioned, every 2D plot needs x and y coordinates, right? So first you provide x and next is y, x comma y. Okay, if you do this plotting, what happens? Oh, sorry, I have given y1, right? Yeah. Okay, so it is going to take each and every x point, and for each corresponding x point, exactly y points are there. So those things also getting plotted. Like for x equal to 0, I have how much? Or x equal to 1, I have 48, and y2, I have 15, correct? So that's what is getting plotted. And for x equal to 2, y2 is nothing but 47. The same thing is getting shown here. So remember, by default, x ticks and y ticks is going to be uh, given in a particular range by Matplotlib library itself. If you want to modify, like if you want to see exact xticks, like right from 1 to 50, all the numbers, then we have something called plt.xticks, which I'll show under editing module, editing or modifying the graph properties. Okay, so let's go with the default first. So this is the default plot. I can enhance a couple of things here. So one is like plt.figure. It is a function. Under this, we have an argument called fixed size equal to, so just provide the resolution. I want 16 by 4. So 16 is your width and 4 is your height. Okay, so this will look better. Fixed size. Okay, so now it makes more sense to have bigger and wider plot to see all the data points. Otherwise, it will be a little dense, and if you are doing a lot of other property visualization, then this will be very confusing, and you will not be able to see the data points properly. So better go with some proper resolution, whichever is best suited for you. Okay, so after plotting, if you see Matplotlib lines 2D, right, it is giving some value, right? So because this generates one object, so to avoid this, what you can do, plt dot show. I don't want to see the object. Always show the plot. Okay, so this is your default with some value. Now let's go with some coloring. Okay, so plt.xy. Now I want some coloring. So if you see here, again, here it is not showing everything, but this star arcs and curve is nothing but your all the parameter whatever I want to use. Okay, so coloring, you can use C or color, or you can directly define like this. So I want red color. Just mention that. Not here. Okay. So instead of by default it is blue color, now it will show red color. Okay. Similarly, couple of other parameters. By default, if you are seeing the continuous line, I want to have dotted line and blue color. You can give this. Okay, so by default, this is line. Now I want to mention dot dot or hash hash. Not hash, basically dotted line. Okay, so this is a broken line. Okay, similarly, you can have, there are so many different options. So like I can have BH. So this is nothing but hexagon. Okay, H stands for hexagon. So all those things you can find under Matplotlib library. Okay, so I would say just dig through it and get to know all the options. Okay, and now if I want dash and dot. Okay, so you can see this kind of line. Okay, so this is about line plot. Now let's see how to smooth the line plot. So why this smoothing is required? Because if you see a lot of data point, right, it is just kind of zigzag plotted because of each point. So sharp turn is there, right? So if you want to convert that sharp turn into curved turn, then you have something called smoothing. So this kind of sharp you will not see. You can smoothen the curve like sine wave, how you see, right? So for that we have something called one special library is there. Import from scipy dot interpolation. So basically we are going to interpolate the data. Interpolation import p one dimension. Okay, so this is the library scipy interpolation. Let me check why it is not showing here. This library should be there. I don't know why it is not showing. So wait, I'm sharing wrong file. Okay. Oh, I think it is interpolate, not polation. Did I mention polation? Yeah. Interpolate, inter 1D. Okay. So what is exactly it does basically? We will get the minimum of x and maximum of x, and between that we'll create so many data points. Okay. And for each data point, we are going to interpolate the data. Okay. So let's say in between, though we have 50 points, I'm going to generate 600 points between 0 to 50. Okay, and for each 600 point, there will be interpolated y value, corresponding y value. Okay, and that is what we are going to plot. Okay, so let's see how to do that. So we have x equal to, or maybe x. First, let's plot the original value. Plt dot plot x comma y1. And here I'll mention plt dot figure is equal to 16 by 4. Okay, so we have already seen that. Plt dot show. Okay, now let's interpolate the data. So what I'll do before, after plotting this, I will just calculate x new data point equal to, so np dot, let's say linear space. So linearly spaced value will be created. Okay, so between x dot min and x dot max, and I want, let's say 400 points. Let's go with new, or maybe 300 points should be good enough. Okay, and this x new I'm going to provide to enter 1D. So let's say int equal to one PRD. What it needs x and y, right? So I have x and y one, which I have already given, and what else it needs? Kind is fine, but I'm not going to just give. Okay, we have linear, quadratic. Okay, let's go with quadratic. Okay, so I can show all the options. We have zero kind also. Okay. Okay, so now interpolate value object is created. This inter is nothing but it is going to create an object, and in this object I'm going to pass x new. So for each x new, it is going to create the new y1 value. Okay, that is interpolated value of 300. So I'm just going to use plt dot. So I have x new, and y new will be what? Your inter, in this you just mentioned x new. Okay, let's see that. Yeah. So it is going to create, as I mentioned, right, we have given 300 value, right? So between 0 to 50, it is going to create another 300 value, and it is going to interpolate the data. Okay, so let's see. First, I went with kind equal to 0. So there are 3 or 4 different kind of kinds. Okay, so I'll give inter1, or let's give inter2, and here I'm going to give linear. You'll see the significant change in the graph. Okay, so inter3, here we have one more thing called quadratic, the best one for smoothing the curve. Okay, and let's plot all of them. So this one is nothing but inter 2 and this one is inter 3. Okay. So what is the problem here? Linear, sorry. There. Okay, so let's plot each graph with different colors, then it will make more sense. So I'm going to original or 0 equal to magenta with dotted line. And this one I'm going to plot with, let's say, blue color with dot. And this one magenta color or maybe black color with dot. Okay. Yeah. So quadratic is this one, right? First, I'll show the basic difference. Let's plot with this. So instead of 0, I'm just going to create quadratic, and this is a third one. Okay. So now you see how beautifully it is interpolating the data. And instead of dot, you just plot with this line. Okay. So you see this sharp turn. Wherever you see sharpness, you see it is smoothen the curve. Okay, by using quadratic, it is applying quadratic equation and getting the more clear data. But here it will go with the zero method and linear method. Okay, different equations are there. Accordingly, it will modify the data. Okay, so best suitable is quadratic. You may use it in machine learning sometimes for data visualization. Okay, so that's about smoothing the curve. Now let's go with the scatter plot. So for scatter, we have plt dot scatter. So whatever name you give, right, the same name that function is existing. So again, for this is also 2D plot. So we need X point and Y point. Okay. This is Y1. Okay, plt dot show. Again, I'll make plt dot figure X size equal to 16 by 4. Okay, so this is your default scatter plot. If you want to change the color, then we have something called C or color. Maybe let's take a look. Yeah, sometimes C also work in some graphs, sometimes color doesn't work. Okay, so you can just give it a try. Similarly, you have so a lot of other parameters also there. So we have X, Y, then S stands for size, C stands for color, and what is the marker, right? So marker, you can give different kind of markers. Okay, then we min and max accordingly, whichever you want. Okay, so edge color. So whatever points are getting plotted, what edge color you want. So edge color can also be different. So let me just try one. So I want edge color of, let's say, black. You see here, for each red point, it is black edge, correct? So this is about scatter color. So scatter plot. Scatter plot will be used for whenever you want to see how my data is distributed. Okay, so for distribution related stuff, scatter plot will be used. And if you want to use some kind of trend, how my trend is there for given data, you will go with the line plot. Okay, so the best thing about the scatter plot is you can convert a given scatter as bubble plot. Okay, so let's see this very interesting one, and this is my favorite graph. Okay, so how to plot the size? So we have something called, let me remove edge color here, and I'll go with blue. Okay, so you see here for each given point, size of the point is same, right? But what if you have, let's say, some value, some data points for Y is more, some data point is less, right? So accordingly, you want to plot the size of that bubble, okay, or size of that point, right? So we have something called size equal to, let's say I'm just giving some factor by 20. Okay, so what will happen? Okay, so this is your 20, and if I give 200, okay, so accordingly, the whole point is getting 200 size, correct? So how to make the size variation? So for that, you need to go with the for loop. So what I'll do using for let's say I, that is nothing but index range. So whatever is the length of y1 data, I'm going to iterate over each point based on the length of y. Okay. So once I go there, I'll just take, since I'm getting the index, right? So I'll take index of x idx and y1 idx and plot them accordingly. But again, I cannot use the same size. So what I'll do, since it is plotting circle, right? So runtime, I can generate the different sizes of circle. Okay. So let's put the area of circle. So what is that? Pi r square, right? So pi, either you can hard code or you can give, sorry, 3.14, or you can use np dot pi. Okay. Multiply by r. So let's treat this value of y as radius of circle. Okay. So I can give y1 idx and star 2, that is square of radius. Okay. So now if you do this, see, it is going to plot a different size of circle. Okay, so seems like it is too big based on the given data point. So we will multiply this factor with very small value, some fraction of value, let's say 0.3 star. Okay, still it is big. So what I'll do, I'll just reduce to 0.03. Sorry, 0.03 I mentioned. Yeah, this is much better. Okay, so that's how you calculate the size of a circle. Maybe I'll just give it to see a little more. Okay, so this is better. So now if you see, a couple of data points are overlapping with some other data point, right? So in this case, what happened, even though your value might be slightly different between each overlap point, so it makes sense to create a transparency between those points. Okay, so that each data can be visualized. Okay, so maybe what there is some point which is smaller than this. So this is like completely hidden, right? So in this case, we have something called, to control transparency, we have something called alpha value. Okay, so alpha is for transparency control, and this value between 0 to 1. So by default it is 1. That's why you see everything is same color, right? So I can give ALPHA equal to, so 0 stands for minimum and 0 to 0.9 is the maximum. Okay, that is 1 is maximum. So let's say I give 0.2. Now see, it makes a little, I think this makes sense, right? So you see here, a lot of data points are almost very, very close to each other. That's why you see all are getting overlapped, right? And it was not visible in previous case. You see here, correct? So if you control the transparency, then this will make sense. And this kind of plot will give you exactly how my data is distributed. Where is my cluster of data? Okay, so let's say so many points are getting overlapped here. You can easily catch my whole data is concentrated on this area. My whole data is concentrated on this area just by looking at this transparency. Okay, so that's about bubble chart. Now let's see next is bar plot. So bar plot you can basically use for whenever you want to have some kind of category values, and each category having so many values, right? So what kind of count is supported, or what kind of count is existing for a given particular category or feature. Okay, so for this we have something called plt.bar x comma y1. Okay, let's plot it and see. Okay, plt dot. So plotting in Matplotlib is very, very easy. Okay, so all you need to do is just run exactly once, and you will understand what kind of bar, what kind of plots are existing, and each plot how you can control it. Okay, so this is your bar plot. Okay, so by default, if you are plotting bar plot, it will be vertical. Okay, so to plot horizontal bar plot, you have something called bar h. Okay, so whichever best needed for your project, you can use whatever you want. Okay, now let's talk about stacked bar plot. So why stacking is required? Well, let's say you have multiple data points or multiple features, and each feature you would like to plot over each other, right? So that's where bar will come into picture, stack bar plot will come into picture. Okay, so how you can do that? plt dot bar, then x dot y1, so y2, okay. So if you are plotting multiple things in single line, right, so that's how your plot will look like, but this is not correct. Though it looks like stack, but this is not correct. Why? Because see, addition of those two are not 100%. If you take a look at this bar, right, so first your orange bar plot has been plotted, and behind that blue bar plot has been plotted. But you see here, whatever is uh, transparent, not transparent, basically whatever is visible, it doesn't mean that your bar plot ends here. This might be coming till here, or till here. You don't know, right? If you control the width, then you'll get to know, correct? So if I control the width, let me show you the difference. Yeah. See here, this is orange plot. And if you take out this line, right, your blue line is not just, from here, it is coming behind this also. Okay. But in case of real stack bar plot, your blue line will exactly start on top of this. Okay. So it will be, kind of 100%, and based on 100%, how much is blue and how much is your orange data. Okay. So how to do that? You have something called x1, xy1 width, and xy2. And here we have something called bottom. At bottom side, I want y1 data. And let's remove this width. This I don't need. Okay. Now you see the difference. This bar and this bar. Okay. So this is your actual bar plot, stack bar plot. So in this kind of stack bar plot, your complete data will be shown in the stack manner. Okay. So here your blue data is also like y1, and this is your y2. Okay. So now you got the plot, and later you can just do the labeling also, right? So how labeling will work? Let's plot that also. So label means like what is the value of this orange, what is the value of this blue. Okay. So first I'll go with this particular graph. Okay, so for label, basically you have to iterate over each value of y1, and accordingly you put the text on that particular bar. Okay, so for that, again, I'm going to use for idx in range length of y1. Okay, so plt dot bar, then for this idx, what is my x value? And for this idx, what is my y1 value? Okay, so it is going to plot, since we are iterating for each data point and we are just plotting without any color, so Matplotlib will automatically choose the color for each and every bar. Okay, so let's see here. You see. Okay, so if you define the color, then every graph, every bar will be of same color. Okay, so how you can do that? I can just choose color equal to, let's say, red. Okay, so this makes more sense, because otherwise you will think, okay, this is different data and from different data, different bar from different data points, but it is coming from same data points. Okay, so from same data points, you always plot the same color. That's what we have used here. That is red. Okay, now coming to the next point, that is how to give the label of that. So for labeling, we have something called plt.text. Okay, so this text function needs at what x and y position, what text you want or what string you want to put. So, okay, so this is my x position and this is my y position. At this x and y, I want to put y value, because bar is nothing but you're representing the y data, correct? I can just put this. Now let's see the graph. Okay. So for each bar, I'm just getting their corresponding values also. So if you want to arrange a little bit left, right, and center, you can play around with the X and Y value. Okay, so let's say each value is shifted little bit right. I can just put maybe X by minus 0.25. Let's see. You see it. Okay, so this is the original data, and right after shifting, you see values are little shifted. Correct. And if it is touching the graph, what you can do, you can just shift the Y position also, plus 0.3. So everything will be shifted little bit up. So I think point is too less. So what I'll do, I'll just make it little more, 0.8. Okay, some value you see it is shifted. Okay, so that's how you control the labeling and shifting left and right based on the text. Okay, and this function is common across all the graph. Wherever you want to do some labeling, use plt.text. It always needs what is my X position and what Y position and what string you want to put that X, Y position. Okay, now let's see the histogram. So histogram is what I think in the previous class I have already talked in Pandas class. Histogram is nothing but it provides the frequency of occurrences of a particular value in the given data set. Okay, so I have, let's say, Y1, right? So in Y1, you will see a couple of values are coming 2 or 3 different time, right? So what I will do, I'll just take the same data set. Let's generate new one, okay? Then you will understand what I'm talking. So X, let it be like this. And Y1 is nothing but, let's say I have 100 will be too much. So what I'll do, I'll just take 50 value and I'm just going to generate 100, okay? So between 1 to 50, I'm just going to generate 100 different values. So definitely you will have some repetition, right? So Y2 is not required. So let's plot the histogram. So plt.hist, you just need to provide the Y1. Okay, so what it will do, it will just find what value repeated how many times, right? So exact count will be there. And each count will be just plotted here. So like 0 to 10, I have some value which is coming these many times, right? So how these beans are getting selected? So beans by default is set as none. Okay. So what I can do, I know I have 50 values. So out of 50, I can generate, let's go with default. Then I'll go with, let's control the width of these bars also so that you can see separate bars. Okay, so we have something called R width equal to 0.8. One is like very close, 0.8 will be less. Okay, now it is better. And I want to control bin size as, let's say 50 bins. I think 50 will be too much, we'll control it. So out of 50, let's say I want to have 10 bins. So the moment you give 10 bins, right? So I'll have like 0 to 1. How many such numbers are there? 1 to 2, 2 to 3, like that, up to 10 bins. Okay. So each number will be counted and that bar will be plotted. Oh, sorry, 50 values are there. So 0, 10, 10 to 20, 20, 30, 30, 40, 50, 50. Okay, so that's how it is shown here. So you can control some other parameter as well. So we have bins, then we have range. You can also give what is density, weights. These things you'll understand once I talk about statistics. Okay, his type is bar. Then we have, I think, ladder or something. So let's see this. Alignment by default, it is mid. Okay, you can control left and right as well. Color also you can control. So color you can give like this. Okay, what I wanted to show, I think. Not orientation. His type. Okay, so let's see what is his type here. Yeah, we have bar stacked, step, and step filled. Okay, so let's control this as step. Based on your need, you can choose whatever type you want. Okay, so this is what step, and step filled is also there. Okay, this is exactly same as step, but it is just filled. Okay, now this is about histogram. So I suggest go with the basic. Then whenever you need some more data, explore each and every option, see what and all parameter it takes, and accordingly you play and get your work done. Okay. Now let's see the pie graph. So pie is nothing but it is kind of, let's assume that is a pizza slice. Okay, each slice, what is their size and what is their label, how much percentage is contributed. Okay. So this will be definitely a circular plot. So I'll just take y value. Let's say I have 2, then 4, then 7, 3, 9, 4, 4, 6, 2, 9. So how many values? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 values are there, right? Okay, so all you can do plt dot py, then just use y. Okay, so each value based on their number of count, number of occurrences, it has taken the slice, and accordingly that size has been generated. Let's say you have 9 multiple times. See what is happening. So whichever value is representing 9, that label will be little more. Okay, so this is with the default data, and now I'm just going to remove this 9 multiple 9s. Okay. Now let's put the data label. Okay, so for that we have something called label here. Labels, correct? So what labels we have, whatever y you have, exactly you just give the value. Okay, so for each slice it is going to put the label as well. So for 9, 4, 4, whatever values are there. Okay, now we have something called, let's beautify this pie chart a little more. So we can control the shadow as well as uh, and explode also, right? So we have shadow, it is boolean true or false. So let's make it true. You'll see shadow, some kind of 3D effect. Okay, now you can see at the edge side. Okay, you can control the angle also. We have another thing which is explode. This is very important part. So explode, like how the slice should be coming out of the center. Okay, so we just put all the numbers. So we have 10 values are there. So if you give 0, 0, 0, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So by default it is 0, 0 degree explode, right? So I'm going to give some value, and accordingly it is going to be exploded. So let's say ninth value I want to explode by 0.9 degree, 0.8. You see here. Okay, so that's how you can control each and every slice accordingly based on your need. Okay. Now, similarly, I want third slice, 0.8 is too much. So what I'll do, I'll just control 0.2. And third slice, I want to make is 0.3. So it will be a little more. Okay, so based on your need, you guys can do that. Similarly, we have one more thing called center. Let me just see. I think you can control center or some kind of angle. Let me just take a look once. So using that particular point, you can control like where your label should be present. Will it be outside or will it be inside? Okay, so center 1, 2, we can give label distance. Yeah, label distance we can give. So this will be, let's say, 0.2, 0.2, X and Y. Is it 0.2, 0.2 or what? From center, how much it is? Yeah. So this is not this. From center, I can have 0.2. Okay, so you see the value from center, it is 0.2. It is basically distance, right? So 100% or 20% distance it has taken from center to outer orbit. Okay, so if you give 0.5 exactly at the center of each slice, it will be present. Okay, so various parameters. So I would suggest please play with that and understand how it works, and accordingly you can use it. Now let's see the stem plot. So stem plot is nothing but it is just going to provide a vertical bar. On vertical bar, it is going to print the show the point of that y data. So plt dot stem. Let me take the same value here. Okay, so where it is. Okay, so it needs x and y1. Could not broadcast. Okay, did I modify the value? Okay, so plt dot stem, it needs x. Looks like this line is still running. Let me interrupt it. Okay, so stem needs x and y. Let me plot this first one and see it is working or not. Yeah, it should work. P dot show. Yeah. Okay, so I don't think so it will be very helpful data or very helpful graph, but yeah, in case you need to plot something, then you can use stem as well. Okay, then lollipop is nothing but create your bubble chart and mix with the stem. That's what is your lollipop. Okay, so what we can do, we can just use this. So these are stem for IDX in range length of y1 plt dot capture x of IDX and y1 of IDX. Okay, and s equal to 3.14 star y1 dx star 2. Let's plot this. Okay, seems to be very big, so I'll just multiply with some factor 0.3. Like this. Okay, that is your lollipop plot. Okay, it looks like lollipop. That's why it is called lollipop plot. There's no direct function for plotting this particular graph. It is just mix of scatter as well as stem. Okay, now let's go to area plot. Area plot is nothing but exactly it is your, consider it as line plot, and below line whatever area you see it is going to be filled. That is what is your area plot. So let's take this number plt dot plot x dot y. Okay, so what I can do, filled area. Why it is not filling it? Because we have to give fill between, not filled area. Okay, so fill between x and y1, whatever is coming, filled. It fill between. Yeah. plt dot show. Okay, so this simple graph, just you need to fill the data or automatically it will get filled between x and y point. That's all. Okay, so color, of course, all remain same. You can just choose it. What other parameter you have, x and y1, where interpolate, step. Yeah, those things not required. Let's go with default. Okay, so color. Yeah, those things are common parameters. So it is going to work. Okay, so mixed plot is nothing but so in the notebook, right? If you keep plotting graphs, right? So every graph is going to be plotted in the same figure. So in that figure, you can plot a number of plots. Okay, so let's say I'm plotting along with a scatter, I'm plotting line as well as dotted line, lot of plots, right? So everything will get mixed and you'll get the mixed plot. So what I can do, plt dot plot x comma y1, and I can have plt dot bar to say 0.2. So why it is not working? Fail to convert value to x is 0. plt dot bar. Okay. Yeah. So it is kind of bridge. Now I can have plt dot stem as well. So for stem width might not be applicable, so you can just remove it. Okay, similarly, I can have plt dot scatter. Width is not required, but I can go with color equal to. Okay, so I think it is getting overlapped. That is the problem. Okay, so I can give size equal to, let's say, 200, and it will be visible. Correct? Yeah. So what else you can have? You can. Yeah, I think you have created line, bar, stem, scatter. That should be good enough. So this is called mixed plot. So in single plot, you can have multiple plots. So we'll see how you can plot different plots in the different way by visualizing in a different way. So for that you have to have subplot. So we'll see subplot maybe today or maybe tomorrow or in the next video. Okay. So yeah, this is about mixed plot. Now let's see the contour plot. What is contour plot? So plt dot. So contour is nothing but, if you see, right, for terrain visualization, they mostly go with contour plot. So how it works basically, you will have a lot of circle in and around, and whichever points are very close or maybe very dense, that is nothing but representing the peak of the mountain. Okay, as you go far away from the peak, you will see line is getting spread, And that's how your control plot is plotted. Okay, so I'm going to generate x equal to np dot random, or maybe in -2 to 2 and 0.25 is my x point, this is my y point. This you give, let's say 3 to 3. Okay, and for plotting contour you need to have something called mesh grid. There is another function called mesh grid, so using that only you can plot the grid. Okay, so what I'll do for that, I'll have x and y. Mesh grid is nothing but, let's say you have a 4 by 4 square. For each point, each small square within 4 by 4, you are going to have x and y coordinates. Okay, so that's what np mesh grid would do. Np dot mesh grid, it needs between x and y. So I can just show how it looks. So these are x, and for each x and x, there will be y point. Okay, so z will be nothing but your contour plot. So what we can do, we can put some kind of formula to create z point. Okay, so let me just take some ready-made formula here, and we'll see it works or not. So np dot sin x with some, I'm taking random value, square of 10, then cos, then take y value, multiply by x, then np cos x. Okay, that is your z. Okay, now you plot plt dot plot what it needs. Is it correct? Contour, right? Not contour plot, because it is already plt. What it needs? It needs arguments, right? So I want x and y and z. It is capital Z. Okay, this is your contour plot, and it is going to generate one object. So let's say CT is nothing but CP is contour plot, and after generating contour plot, I can put the labeling also, whatever Z points are there. So we have something called plt dot c label CP. Okay, plt dot show, then plt dot color map. If it is applicable, it will show the color map also, or C map. I don't know it is there or not. Let's have a look. So it is not color map, it is color bar. Color bar. Basically, it will represent the value of the dense the color, bigger the value. Okay, so you see here minus, and this is your the darker color, or lighter color means higher value, darker color is lower value. This is minus 1.2. Okay, so I think right now it may not make more sense, but just be aware contour plot is also used. So in case your project needs this, then probably this is a way to draw it. Okay, so let's see the next one, that is image plot. So image plot is nothing but basically it is used for heat mapping. Okay, so heat map, there are a lot of different way to generate it. I'll show in the Seaborn also, but let's see how to generate it quickly from Matplotlib. So I already have y points. Okay, so whenever you have NP array, what you can do, you can just generate it. Let me create a shape first. So y1 dot size, how many values are there? 50, right? So I'll just do y1 equal to y1 dot, let me make y2 reshape 5 by 5, 10, right? So let's have 10 rows, 5 columns, y2. Okay, so whenever you have two-dimensional array, you can easily generate that array or convert that array into image form, right? So for that you have plt dot imap or imshow. All it needs is your numpy array. Okay, so now you can see. Let me make it bigger. Plt dot, or what I'll do, I'll just take 5 rows, 10 columns. It will be much better. Okay, so this is your image show, and for each pixel. So why it is called image show? Because pixels are or images constituted by pixels, right? And each pixel will have different value, or different grayscale, or different color bar, right? So now, what is my value for this pixel? How to do that? So what you can do for IDX, or maybe X in range. So range, I have X values are how much? 0 to 8, right? Or mostly 10, right? So I can give 10. And for each this, I have Y also. Y in range, let's have X and Y. I have total 5, right? Just give 5. Okay, so plt dot text. I want to put the label, correct? So what is my X position? I have X position as X. What is my Y position? That is Y. So for X, 0. And what is Y position? That is this. And what is my value? So Y2 of X and Y2 of Y. Because X row, Y column, right? Let's see it fits or not. Index 5 is out of bound, X is 0. Okay, so I think we just have to change it. Y to X. That's all. So Y value is nothing but your 0th row, okay, and X column, that is 0th column, okay. Similarly, this and that, you can just plot all the values, okay. So that's all about image show. This is more simplified in Seaborn, so I'll just use from Seaborn only, heat map, and a lot of color options are provided, okay. So you can have something called CMap also. Let's go default. There is something called CMap, and there are almost close to 100 or 200 different maps are there. So red and blue. If it is not there, then you can find out what is supported color. These are the color maps supported. Let's say I want to have red, yellow, and green, correct? So I can just copy and paste it here. Yeah. Okay, guys. So yeah, that's about image show. That is image plot or n-dimensional array plot. Okay, so I think this is good enough for today. It is too much. So let's complete tomorrow remaining things, like how to edit the property of different plots, and how to do 3D plotting, and how to use dual axis in the same plot. Okay, and how to save the graph or plot in the local disk. So that we'll see tomorrow. That will be very helpful. And tomorrow will be the end of Matplotlib. Okay, guys, so that's all from my side today. Thank you so much. Those who have not subscribed my channel, please do subscribe and like the videos. Feel free to give comment. I'm not getting comment from most of the guys. And if you are understanding, that is good. If you're not understanding, please give the comment. Okay, thank you. Bye-bye. Hey guys, Pankaj here. Welcome back to my YouTube channel. In last video, we saw Matplotlib part 1. There we saw a lot of 2D graphs, and right from line plot, scatter plot, bar plot, histogram plot, and a lot of other plots, right? So today we will see how to edit properties of those 2D graphs. Okay, so let me share my desktop. Yeah, so this is the previous part where we saw up to image plot, right? And after that, editing properties was left out. So we'll see today. So these are the topic I'm going to cover today. So we'll see how to edit property of plots, and how to do labeling and marking in scatter plot, how to draw horizontal or vertical line in any of the plot. Okay, we'll see in the example the line plot. Then what is subplotting and what is the resizing of the subplots, and how to access x-axis with sharing basis. Okay, or basically how to share the x-axis when you have two plot side by side. Or how to access y-axis when you have top to bottom plots. Okay, we'll see 3D plot also. We'll see how to do dual axis plot in a single plot, Okay, then we'll see how to save the graph in the local disk. And the last example will be how to animate the plot. Okay, so let's start without wasting time. So I have loaded those library, that is NumPy, and for generating the random data. Then Pandas data frame, mostly it is not required, but yeah, let it be there. And matplotlib.pyplot as PLT. Okay, so this line I had mentioned why it is required, because if you want to plot the graph in the notebook itself without popping out a separate window, you can use matplotlib, this magic command, and with parameter called inline. Okay, so let's generate the random data. So I'm going to generate 50 different points for x-axis, and for y total 50 points for two different y data. Okay, that is y1 and y2. So let's run it. Okay, so here is my print x, and then print y, print y2. Okay, yeah, so this is your x point 1 to 50, and now it is going to generate random 50 points between 1 to 100, that is this one, y1 and y2. Okay, so now let's generate some scatter plot, and we'll see how to edit different properties of a plot. So whatever editing property I'm going to show, right, that is common across all kind of plot. Okay, so I'll just take one scatter plot. Okay, and same kind of property you can use for different plots also. So let's generate the plot first. Plt dot scatter, so x dot y1, and I'm going to use plt dot figure x size equal to 16 by 4. Okay, so to make it looking better, yeah. So now let's see how to label the how to label and marking those points in the scatter plot. Okay, so first of all, we are going to, since when we are going to mark and put a label for each point, right? So when I say each point means you are going to iterate over each and every data point of that scatter plot. Okay, so definitely you are going to use for loop. Okay, so let's use it. So for idx in range length of y1. Okay, so you can take y1 or x1 because both are having same size. So now for plotting, I want to use x of idx, y1 of idx. Okay, then color equal to, let's say, red, and alpha. So those who have not seen the C and alpha parameter, please watch the previous video. C stands for color and alpha stands for controlling the transparency of the point. Okay, so if you don't control the transparency, then a lot of points will get overlapped and you will not be able to see the labels. Okay, so I'm going to set as 0.2. So let it plot. Okay, meanwhile, let's find out other parameter. Okay, so looks like, yeah, I'll put a size also, np dot pi, that is 3.14 multiplied by y1 of idx, and take the square, so that area of the circle will be generated. So looks like this library is eating a lot of memory in my PC. That's why it is becoming slow. So now bubble plot is generated. I am just going to multiply by a small factor so that circle size can be reduced. Okay. Yeah, I think this is much better. Maybe I can use 0.25. Okay, I'm going to make the plot little bigger. So I'll just use 16 by 6. so that width will be a little more and I can accommodate more points. Yeah, this is much better. So next what we are going to do, we are going to put only those points which is, let's say, greater than 60. Okay, so I'm not going to put a label for each and every point. Rather, I'll put a conditional based probability and the label. So if y1 of idx is, let's say, greater than 60, label only those points. Okay, greater than 60, then put a label. So plt dot text. Now x of idx, then y1 of idx, and what label I'm going to put, y1 of idx, that is nothing but your y value. Okay, so let's highlight only those points. So circle is bigger, so what is the reason behind that to be bigger, right? So this is the reason. So their value is too much or value is higher, and since it is satisfying the conditions, that's why only those points are getting labeled. Okay, now let's do some more property. So let's say if size are bigger, then I want to have those points to be highlighted as a star. Okay, so here I can put marker equal to star. Okay, so, and of course we have to remove this condition. So what I will do, I'll just copy paste. Okay, so when you want to highlight one specific point with different marker size, right, then definitely you need to remove this particular line. Otherwise, every line will have circle as well as star. Okay, so I want to highlight those, else I want to plot other points with different marker. So let's say I want to make this as diamond shape or maybe triangle shape. So let's see the difference now. Okay, so let's say whatever points are bigger, then those are being treated as star and others are left triangle. Okay, and you can change the color as well. So I'll make C equal to, let's say, blue. So keyword repeat. Okay, here I can make it blue because I made it 2 times. That's why it is giving the error. Okay, so this is your scatter plot with 2 different marking and 2 different colors, and based on the conditional statement. Okay, so that's how you can put the labels. Now let's see how to draw horizontal or vertical line in a plot. Okay, so I'm going to take here line plot, so that understanding of horizontal or vertical line plot will be easy. Okay, so let me take this example. The very first plot, and let's modify this. So this is not required. Plt dot plot, and let's plot x and y1. Okay, so, and I will make it little less width. So now you have the line plot, right? So assume that you are pointing some threshold of y level or x level, right? So definitely at that point of time, you need some horizontal or vertical line to be plotted. So we have something called plt dot ax v line. That is nothing but vertical line. So let's say I want to put a crossbar between line 20 to 40. Okay, or maybe that is denoting as a threshold level. So ax v line, what it does basically, you want to plot a vertical line at what x position. Okay, so my x equal to, let's say, 20. Okay, so now it is going to plot a line in that particular x vertical. Okay, then you can mention color equal to, let's say, red. Okay, now I want to have another horizontal line, that is ax dot h line, that is horizontal line. So for horizontal line, you definitely need to have y position, right? So I want to plot from, let's say, 60, and this is my y, and I want to make it red. what is this? 60, not y. Okay, so that's how you can plot the various threshold level and between x and y coordinates. Okay, and of course a lot of parameters are there. So we have something called, let's say, line width also, right? So I think L width is nothing but your line width. You can definitely control that also if it is required. So then you can have like solid cap style, solid line style. So different kind of properties are there for line. So of course it is required. You guys can definitely explore it. Otherwise this is good enough. So you have something called line width. So what I can do here, line width equal to, let's say 4. Okay. And this is also line width equal to 4. Now it looks better, right? So this is about plotting horizontal or vertical line. Now let's add some kind of annotation. Okay, so annotation is nothing but, let's say you would like to point out this particular point with some arrow or with some text, right? So we have something called annotation, plt dot notate. Okay, so what it needs a text, right? So what is my text? Text equal to, let's say this is threshold. This is threshold cross. I'm just mentioning, okay. And after that, it needs what x and y position. So if you see here, x and y, right? So x, y equal to, of course, you are passing x and y coordinates together, right? So it should be in the form of tuple, right? So x is 20 and your y is 60. So exactly at this particular point, it is going to point out the arrow. Okay, so it is going to be like this. Let me just draw it manually first. So where is that annotation? And is my arrow. So it is going to be something like this. From here to here. And here you can put your text. This is threshold cross. Okay. So let me remove this. Okay. Now let me add the text. So what is the next value? XY. Now you have given the position, right? Now XY text. What exactly text you want to put? So you can put here. Oh, basically this is the position for XY text. So it is going to, arrow is going to be pointed here, but from where to where? So let's say your text is going to be pointed from, what shall I mention? Maybe I'll mention 21, 21 to, let's say, 80. Let's see what it does. Okay, it is pointing, but it is not showing arrow, right? So let me make 30. Okay, but where is the arrow? So I think we have some more parameters to show the arrow. Let me just take a look. So there is something called, let me just find out, arrow props XY text. $20 and $85. If I put, then what will happen? $20 to $85. I'm just going to use another line. Okay, so this is horizontal line, XY 15. So I'm just going to mention 20, then 80. And XY text 30 to 85. Yeah, this looks better, right? So what is my position here? X5 20 80 exactly, and this is going to be 85, right? And 30, from 30 to 85. So what you can do, instead of mentioning 85, I'll mention 60. Then your arrow point will be exactly at the threshold level. Okay, so this is 30 and this is going to be 60, and this should be basically a 60. And this should be 80. Yeah, so you need to play with the parameter like this so that you can exactly get to the exactly same cross. Okay, and definitely we have something called arrow property, so it will take the parameter in the form of dictionary. What is the face color of arrow? That is black, and it is shrinking. So shrink is not basically required. You can just remove it also. With that also it will work. Okay, so that's about plotting the horizontal or vertical line. Now let's talk about subplotting. Okay, so basically guys, subplot is nothing but, let me just draw a small figure here. So subplot is basically your figure is divided into this particular area, right? You have one particular area, and in this dedicated area you want to have multiple plots. Okay, so I'm going to divide this particular plot in, let's say, multiple area. So I'll divide by these many rows, these many columns. Okay, so what will happen now? I have how many columns? 1, 2, 3, and 4, right? And how many rows? This is one row and this is another row. So total 8 figures I can put in this particular figure. Okay, so this is basically a figure. In this figure, I can divide n number of rows and columns, right? So each row and column indices will be denoting to one figure. Okay, so let me remove it and just show the example. Okay, so what I'm going to do now, so for that you have something called subplot. So plt dot subplot. So subplot, you can there are two ways, as I mentioned, number of rows and column, right? So I have number of rows 2, number of column 2, and what is the figure number? So in this I have figure 1. Okay, and after that you can just put plt dot plot x dot y1. So since we have 4 figure, so it is going to divide one figure into 2 by 2 column, 2 rows and 2 column. Plt dot show. Okay, so I just have given one figure, right? So similarly you can have, let me just quickly draw some more. You just need to do, so this is my second 2 row 2 column, and what is the figure number? 2. So now this time it is going to put another figure. Okay, similarly I can put 2 by 2, this is my third figure, and 2 by 2, this is fourth figure, correct? So see here, this is the main axis, and in that axis this is one figure. In that figure we can put a number of plots. Okay, that's why it is called subplot. So one more thing to remember, it is not necessarily like you always put 2 comma 2 and comma, right? So this can be given as in this form also. So 2 2 4, so 2 rows 2 columns, and this is my fourth figure. This is also fine. It is not going to throw an error. Okay, so this is about subplotting and resizing. So try not to divide one figure in more than 3 rows or 2 column, or 2 rows or 3 column. Okay, otherwise your data will look very clumsy, graph will be very clumsy, and you will not be able to interpret the data, or if some labels are put, you will not be able to recognize them properly. Okay, so this is standard way of dividing your plot into 2 by 2. Okay, so we have something called subplot with shared x-axis. So why to share x-axis? If you see here, my x values are almost same for all the figure, right? Then why to, let's say if I have already given x-axis for this, then this doesn't make any sense to have x-axis for these two graphs also, right? So what I can do, I can share the x-axis of this particular graph with this also, or similarly y-axis I can share with this along with these graphs. Okay, so let's see how to do that. So we have something called ax equal to, since plt dot subplot is going to generate the figure, right? So this time I'm going to generate, let's say, 2 row and 1 column. Okay. So this AX will return some kind of object. I think subplots. Yeah. So once you give this, right, it is going to create a subplot of array, right? So in this array, my first, it is going to create list of axes, right? So this first axis from that list denotes this particular graph, and second element of that axis denotes to second graph. Okay. So now once we have access object, from this object you can plot. So let's say first figure, I will leave it to you guys, and I'm just copying pasting. Ax of 0, I want to plot its line. So x dot y1. No attribute plot. Okay. Let me see why it is not giving. Okay, figure and attributes are there. So if you see here, yeah, this is a mistake. So it is going to generate double of all the things, right? So one first element will be figure and second element will be array of all the plots, right? So I could have mentioned two parameter here, figure, that is FIG and AX, right? Now in this I can plot. So yeah, this looks better now. And here, since both are having same data in the x-axis, I can use one parameter called share x equal to true. Okay, and now for the first figure I'm going to use, let's say I'm going to put scatter x dot y2 and plt dot show. See what you notice here, in the first graph it is not at all showing any x value, right? Because I'm sharing the x-axis. So this is intelligent enough to take like where x-axis is shown, and for the top graph it is not going to show x-axis. Okay, so that is about sharing x-axis. Now you can share x and y together. So how to do that? Let's create some more graphs here. So I'm going to create 2 by 2, and this is share x, and because for sharing y you should have another graph, right, which is having similar y axis also. So share y equal to true. Okay, so this is going to provide another things here. So let me just show you guys. If you see here, right, it is having 4 figure, right? So the moment I give share x true, share y true, you see here the y axis columns are empty because this is going to have similar value. Okay, so in this we have in the first position 2 plots, that is for the row 1 we have 2 figure, right? That's why 2 graphs axes are there, and for second row we have 2. So you have to have multiple subscript. Okay, so how we can do that? So ax of 0, so x of 0 is this. In that I'm going to plot another graph, so that is 0th element and this is the first element. So I'm going to take 0th element dot plot, let's say x comma y1. Let's quickly plot them. So 0th row first column, and first row 0th column, first row first column, and then plt dot show. Okay, so see here x-axis is also shared and y-axis also shared. That's how you share it. Okay, and I think this parameter is not required here. Yeah, this is fine. So I hope it is clear. I think you guys tried and you will understand. Okay, and you can control a lot of other graphical properties which I have already shown you guys. Okay, now let's talk about how to do 3D plotting. Okay, so for 3D plotting we have a library called Matplot, that is mplot3d, and you need to import xs3d. Then only it is going to provide. So far we have been seeing x-axis, right? So let me just plot here. I will just show with the help of annotation. Okay, so far we were trying this, right? This is your X and this is your Y. Okay, now you are going to have another axis called Z axis. Okay, so for this particular given X and Y point, what is my Z point? Okay, so what you can do, we are going to kind of put some formula to calculate the Z by providing the X and Y value. Okay, so that Z, deciding the formula, you can have any kind of formula like parabolic equation, quadratic equation, any kind of equation which can take the value of X and Y, calculate the data and give the output for the Z. Okay, so for this given XY, what is my Y point? What is my Z point? Okay, for this particular XY, what is my Z point? So basically it is going to put in 3D space. So this is X and Y, this is the point, and the moment you do some formula calculation, it is going to lift the point or put it down in the 3D space. Okay, so that is what your Z point. So that's what we are going to see now. So let me just put some values here. So we already have values. Let me copy paste. X and Y. Let's take X and Y. Okay, and for Z, what you can do, you can take the, for let's say some quadratic equation. Okay, so X multiplied by 2 plus Y to the power 3 and take the division by X to the power or X multiplied by 3. Okay, so I'm just putting some random equation, so you are going to get some value here. So this is your Z value. Okay, so for given X and Y, this is your Z value. Okay, so yeah, that's all. So now what we have to do, we have something called plt dot subplot, let's say 111. So I'm just going to have one single figure, and there you need to enable one point called projection, because I'm going to project that particular 2D figure in the 3D space. Okay, we need to enable it 3D. Now you just plot plt dot line plot, or maybe scatter will be better to visualize all the points. X at this, at X at this Y, what is my value? Is it plt dot show? Okay, so what is happening here? Why it is pointing like this? X linear space and okay, I think values are too much, so I need to reduce the point. So let's have 20 points, and here between 1 to 10 I'll have 20 points. Okay, this looks better. Okay, so now we can increase the size. So I'll take 50 points, and here also 50 points. Okay, looks better. And now if you see, it is pointing whole graph in inline, right, in the notebook. So for 3D graph, it makes sense, you can plot like this. But if you want to visualize in all 3D makes sense when you are able to visualize, right? So for that, you need to enable one particular point called, again, magic command, Matplotlib. I want to put it, just enable like this. If you put inline, then it is going to point here. If it is not inline, then it is going to pop out. Okay, now the moment it is pop out, this looks very beautiful. If you are able to just click here and now hold your mouse and just rotate it, that's all. Okay, so basically you see this is my X point, 1 to 10, or maybe a little more value, and this is 0 to 50, that is your Y value. Between this xy, I have taken the formula, right? That is nothing but take square of x plus y cube, add them together. So while adding, you see the point is lifted towards z-axis. This is your z space. Okay, so if you are putting some quadratic equation, parabola equation, then it is going to definitely plot the curve. Okay, so it is up to you what you are plotting and how you are going to show that. So this is about your 3D plot. Similarly, you can have line plot also. So let me just show you. PLOT. Now it is going to show the line now. Okay, so this is in 3D space. You can visualize like this. Okay, I think you can do bar plot also. Let me just show. Should work. Okay, for this xy, what is my y? So basically it is kind of surface is getting plotted. Okay, maybe because everything is getting, touching together. So that's why you see simple plane. But maybe you can play with some more property and you can understand how it is getting plotted. So for now, I'm going to disable this and plotting everything in single line. Okay, so for that, you can do inline. Let me just mention here also. If figure to be popped out, then use this. This line. Okay. If figure to be plotted in notebook, then uncomment this line. Okay, so I'm just going to comment this. Now you are going to run this. What is happening here? I think it is not accepting the command. So what I can do here, I'll just write here. Okay. Yeah. So that's about 3D plot, guys. Now let's see the next one. So we have something called dual axis plot, right? So this is similar to what we have plotted here. So what I am going to do now, how to plot a dual axis, all you have to do is just enable something called twin-x. Okay, so figure plot a, maybe what I will do, plt dot, just a minute. So plt.x1, and I'm going to plot plt.y2 as well, then plt.show. See what is happening here. So two line plots are getting plotted in the single plot, right? But since both are having different y object, so different y value will be plotted in the same plot. Okay, so why it is not coming? Let's wait for it. So what will happen in the single plot, two different y values are there, right? So for this particular graph, maybe the first one is blue and second one is orange. So for first one blue, this particular y plot will be taken, and for second one, if you want to have separate y value to be taken, then we have something called plt dot twin x. Yeah, okay, so just enable it and see what is happening here. See, so automatically it has factored those values for y, and for the orange one, this is what is shown. Okay, so there could be some need where you need to have two different plots in a single plot and two different y value to be shown. Okay, so by enabling twin-x, you can just enable the dual axis to plot dual y-axis value. Okay, so let's see the next one. How to save the graph in a local disk. Okay, so let me take this only, and we have something called plt dot save figure. Okay, so save figure takes a lot of arguments. So by default, you just give the file name. Okay, it is going to generate the file in that format. So let's say dual axis plot.jpeg. So we have various formats supported. You guys can take a look what other format controlling DPI also, what is the face color, edge color of those figure. A lot of parameters are there. I would suggest please play with that. Okay, so mostly this is what you need as a default one. Okay, so once you save, make sure that you save the figure before showing, because after showing that object will get clear. Okay, so first you save it, then you show the graph, so that you can see here, as well as you can save the file as this dual axis plot.jpg. Okay, yeah. So that's about saving the graph in the local disk. Now let's see the next one, how to plot the animation. Okay, so why this animation is required, right? Let's say you are getting real-time data. Okay, so it makes sense to plot the real-time data in a real-time environment, correct? And do the visualization as a real-time, not just you get the value and just plot them and your plot looks static, though you are getting the real-time value. Okay, so there it makes sense to animate the plot. So let's see how to do the animation. So for animation, we have to write one function so that we can call that function again and again and keep clearing the graph and keep plotting the data. Okay, so I'm just going to create a function here, animate, and this needs 3 arguments. Okay, so first argument is nothing but your, you can give any character name. I'm just going to give AI, that is standard what we have seen in Matplotlib documentation. Okay, then your x value, and that is x's, and y's value. Okay, so here let me just mention I is nothing but inbuilt variable to increment the frame, because we are going to automate, right? So frame by frame it is going to it is going to be populated in the graph. Okay, inbuilt variable to increment frame number. I'm just going to show very simple example so that you guys can automate and use the animation. Okay, so here let's define some value. So yeah, before that we have to import one library also from matplotlib.pyplot animation. From matplotlib.animation import animation. Okay, so let me see if this is not correct as animation. Okay, this looks correct, and now it's time to create the object. So I'm going to have access equal to some empty data, ys equal to some empty data. Okay, now I'm going to create some random data and keep filling the axis in ys. Okay, so let's say my ys is nothing but ys dot append. I'm going to add random data in this. Okay, np dot random dot ran int, let's say minus 22 plus 30. Okay, so I'm just random dot run int will generate integer value, single value between given min and max. Okay, now whatever, so ys will keep getting appended, right? So accordingly, let's say I have ys 4 values, so differently 4 different data points should be there for x-axis also, right? So I'm just going to use access dot append length of ys. So let's say first time ys got appended, so it is going to have only one value, right? So length of ys will be 1, so x's will get appended as 1. Next time 2, 3, 4. So that's how I get that's how access point will get created. So it is like 0.1, 0.2, 0.3, 0.4, and some random value for the y in that point. Okay. Now access, I'm going to limit x value because every data I'm not going to plot, right? I'm going to have, let's say I'm getting 100 value. In that 100, I'm just going to take last 20 values or last 30 value or last 50 values based on the need. So I'm just going to take access, let's say last 10 values I'm going to plot. Okay. Similarly, y is last 10 value. Okay. Now time is to plot the figure. So let me create a figure or a plot by creating the object. Okay. So we have something called figure equal to plt dot subplot 111. Okay, plt dot subplot dot 111, or maybe I can create the size also, or figure size is good enough. So that we can have little bigger figure equal to, you can have subplot also, anything is fine. Fig size equal to 16 by 4. Okay, then you can have subplot together or later also. Ax dot equal to plt dot subplot just 111. Okay, so basically one row, one column, and one single figure. Okay, so now since my plot is getting plotted in the figure, right? So I have to make sure that whenever next time I'm going to plot, existing figure needs to be cleared out. Okay, so that access object, you have something called clear. Okay, then in that X you just plot it. Plot what I'm going to plot, x's and y's. That's all. Then plt dot show. Okay, now my function is ready. Now the time has come to automate this animation. Okay, so in this animation we have something called func animation, so which is going to generate a object. So I'm just going to generate any object, animation dot func animation, which is going to take a couple of arguments. Okay, so why it is not taking? Is there any mistake? Or it is not? Okay, anyway, so it is going to take the figure. So I'm going to automate this figure. Okay, and what function I'm going to take, that is nothing but your function name is animate. Okay, so that is your animate function. Why it is not taking? Why this library is not existing? From import or from okay, so typo is here. Import Matplotlib animation as animation. Okay, there's no separate animation function in this. Okay, so now this is supposed to be working now. Yeah, now it is working. So first argument is nothing but your figure. So I have already given. Then the function. So func is what? The function which you are going to animate. So I have given animate function. I'm just going to call it. After that, what it needs frames. Okay, so frame I'm not going to touch. F arg, that is nothing but your function args. Okay, F args are nothing but your x's, that is in the form of tuple, and ys. Okay, so remember guys, since we are going to pass the function as object, make sure that you don't use the bracket here. Otherwise, this will assume that you are running the function here itself. Okay, we are passing the object, so we have to write animate only without bracket. F args is whatever argument has been taken by that function. Then we have something called interval. At what interval you are going to put or plot the elements in the graph. Okay, so let's say every 200 millisecond. Okay, so that's all. Now here plot should be here. Let's run it. Okay, there is no data. What is missing? Let me just check. Okay, so let's pop it out and see. It is plotting. Okay, so it is plotting, but yeah, this looks great. So instead of plot, let's say I want scatter. Ex dot scatter xs dot ys. Now I think both points are getting plotted. Okay, so dot as well as your scatter plot. Okay, so that is about this. So now good thing about this, you can let me have more points here. 20 20. So looks like delay is little more. I can reduce the delay and make it little faster. So I'll just have, let's say, 50 millisecond. Okay, this will be faster, but since my PC has become very slow, that's why it is plotting very slow. Otherwise, this would have been a little faster. Okay, so yeah, that's how you plot the animation or animated graph. So what it will do, so if you see here, right, I'm plotting last 20 points, right? So after 20 points, you'll see it will start truncating these points. So let's wait for some more time. So you see here, this is 18 point down 20. Now you see here, now it started truncating, right? Because I'm limiting last 20 points only to be plotted in the graph. Okay. Now this is not just true for plot or scatter. This you can automate with bar plot, histogram, or even you can put a 3D plot also. Okay, so let me just show you guys. So this is about 2D plot. Let me just automate bar plot. Okay, and use equal to read. Okay, let's add some more cosmetics here. I'll put plot as well as, so line will also get plotted, and let's use black color. So along with trend, it will show the bar also. Okay, see how beautiful it is animating the graph. So this will be very helpful, guys, when you are plotting the real-time data. Okay, so that's about 2D plot. Let's put 3D plot inside this automation. So 3D, I'm just going to copy paste the previous 3D graph. So all you have to do is this. Okay, just projection 3D and calculate the y-axis, that's all. So where is this? So remember, guys, for 3D plot, projection 3D argument is very much required. Then now the moment you have x's and y's, what you can do is, now I'm going to operate over numpy array, right? So I'm going to make this as np dot array numpy array, np dot array numpy, and let's have zs equal to xs square 2 plus ys square 2. Okay, now I'm going to have a scatter plot XX, YS, and ZS. Let's see if this automates or not. Yes, it is very well automated. You can rotate the point and just see how beautifully you can see incoming and outgoing data points, okay, in the x-axis. Okay, let me add some more color here. So what I'll do, I'll just make a little fun element here. So we have been increasing the size, right, by iterating over each data point, right? So for IDX in range length of, let's say, YS, right? And now let's plot your scatter by IDX, Y of IDX, and Z of IDX, and use size equal to 3.14 star ZS IDX star 2. Let's see. Oh, it is damn big, that's why. So I'm just going to use red and multiply by some factor that is 0.03 to make your circle a little smaller. Okay, still it is too big. Maybe let's remove this point. Yeah, this is better than earlier. So you can see all the graphs are getting plotted. Okay, let's make the alpha also here. Alpha equal to 0.4. Okay. Okay, this is much better. I think now you got the idea, right? How you can animate the 2D graph as well as 3D graph. Okay, so guys, these things will be very helpful when you are going to learn support vector machine learning. Okay, so when you have a lot of complex equation where you are not able to visualize like how my data is separated, right? That's where your 3D plot will be very helpful. Okay, so I think you should learn how to plot 2D as well as 3D. Okay, and this is going to be very helpful in machine learning. Okay, so I think that's all from my side today. I think you enjoyed this video. You have learned a lot of new things in the graphing. Okay, and definitely you are going to make better data visualization, or whenever you are going to create dashboard, right? These kind of graphs is going to be very helpful. Okay, so yeah, that's all for today. I hope you enjoyed and you have learned a lot. If something or some concepts are not clear, please drop out your comment in the comment box. And those who have not subscribed my channel, please do subscribe. Okay, thank you so much, guys. And after this, I'm going to start Seaborn tutorial, which is written on top of Matplotlib. So you'll see a lot of advanced graphing. And here you would have seen, right, a lot of so many lines of code we are writing, right? For though it is very helpful because once you know Matplotlib, you can work on any kind of advanced plotting library. Okay, that's why I have shown with the Matplotlib first. So in Seaborn, multiple complex graph you can generate by just using 1 or 2 line. Okay, and a lot of parameters are supported, and I'm going to talk about this more detail with a lot of examples that will help you to understand Seaborn very easily. Okay, guys, so let's find out. Thank you so much. Bye. Hey guys, in previous video, I think I missed to share that animated graph in 3D graph, which was popping out from the window. So I'm just going to record short video and just to show that like how 3D graph looks, okay? And I'm going to upload on top of that previous video. So let me share my screen now. Okay. So the graph which I missed to show you guys, that is this one. So 3D plot along with line, right? So I'm just going to use this pop. Okay, so now I'm going to share this. Yeah, so I hope it is visible for you guys. So this is what is popping out from the notebook, and it will be visible. Okay, so that's all. You can just hold your mouse, rotate it left and right. And so 3D graph, why it is required? Because those points, right, if you see in 2D plane, if you just see from the top, right, you are not able to see like how, if multiple points are there, you will not be able to distinguish how they are separated. But the moment you start rotating, they may be separated by, you know, by couple of values in the z-axis, right, up and down. Okay, so that's where the 3D graph will be helpful to separate out, to see how values are separated. Okay, so this is what I wanted to show you guys. And another one is like how it is getting automated, right? So let me run. Okay, so before automation, I would like to show the graph where I'm plotting 2D. This one, line plot. Okay, so line will also look like this. In case you are plotting, it will be like zigzag, but from the space you can easily see like how they are separated. Okay, so let me share this in case it is missing. Okay, so this is your line graph, and hold your mouse and you can just drag and drop. Okay, and now the next one is animation, right? So for animation, I have explained very clearly like in previous video. So I'll just show like how the animation looks like with 2D. Yeah, so let me share my screen. Yeah, so this is your 2D graph, how it is getting plotted. So after 20 points, you will see this particular section will, you know, start getting truncated because only last 20 data points I'm going to show. Okay, so this is about 2D graph. And similarly, I have plotted 3D also. So in 2D, I'll show the bar plot now. Yeah, so you can see now how beautifully it is getting plotted with trend line also. So bar up and down and along with the trend line. Okay, so that's about bar plot. Now let's see how you can automate 3D also. So 3D, I'm taking the scatter plot. So this is also going to be looking very similar. I'm just going to share this. Yeah. So points are grown very big, but once you run in your notebook, then probably you can easily distinguish. Okay. So let me just run it once again with a smaller point, maybe 0.2, and immediately I'll share. Okay, so I hope you are able to see now. So this is getting automated and points are getting plotted one by one in the x-axis and their corresponding z value. Okay, so based on the point value or how big is that, because accordingly that circle will be bigger. Okay, and here also you can hold your mouse and just rotate it left and right and do the visualization from all three angles. Okay guys, so I had to make this video very short because in the previous video this sharing was missed. Okay, so thank you. Bye bye. Hey guys, Pankaj here. Welcome back to my YouTube channel. So today I'm going to talk about another plotting library that is very famous and very heavily used in data science. Okay, so its name is Seaborn. So you have already got the idea now, like how to do basic plotting in Matplotlib, how to edit the various properties of the plots. Okay, so on top of that, an advanced library is Seaborn. So in Seaborn, you will be able to do a lot of data visualization in a very short span of time, and you can do any kind of plot very easily, okay, without writing multiple lines of code. Okay, so let's go to the topic, and I'm going to share my screen. Okay, so these are the topic I'm going to cover under Seaborn. So we'll see a lot of various plot which we have already seen in Matplotlib, but how easily you can plot and what are other factor behind Seaborn to use it, correct? So the main reason of Seaborn plotting, why I'm telling to use, or maybe in future if you are going to use it, right? So you stick to Seaborn because of two reasons, or maybe one solid reason is, so in Matplotlib, right, you have seen at least in 2D plot you can plot max two variable, right, x and y, correct? In case of Seaborn, you can plot at least 4 to max 5 dimension of data in single 2D plot. Okay, so I'm going to show this along with the example, then you will understand what I mean to say about like 4 or 5 dimension of data in one single 2D plot. Okay, so that is the beauty of Seaborn. So let me start like what and all I'm going to cover today. So we'll see what is the base library for plotting Seaborn data, and what are the various data set available in Seaborn library. So you don't have to load externally. Seaborn itself provide a lot of toy data set. I think 15 to 20 data sets are there, so which we'll see shortly. Okay, so how to do various plotting, how to change various plotting style of Seaborn. Then we'll see different plots. Okay, count plot, bar plot, line plot, histogram, distribution plot. Okay, ECDF, that is nothing but empirical cumulative distribution function plot. Then we'll see scatter, then box plot, then boxen plot. Okay, then we'll see what is swarm plot and how to do that. Violin plot also, then strip plot, pair plot, and heat map. Heat map is a very important plot because you are going to use it very heavily day to day, because once you start learning machine learning, there is something called confusion matrix. Okay, so once you do data prediction, you need to basically showcase using data visualization. Okay, so their heat map will be the best plot for showing confusion matrix. Okay, so let's get started without wasting time. So what is the library which we are going to import? So first I'll import numpy as np. I may use some random data, that's why I'm importing numpy. Then import pandas as pd. So panda also will be used in case we are going to generate data frame using random data of numpy generated data. Okay, then next is import matplotlib dot pyplot as plt. So why matplotlib? Because though we are going to use Seaborn, but as I mentioned, it is written on top of Matplotlib, right? So in case any specific editing of the properties of the data or editing the properties of the graph you want to do, then PLT will be the right way to do that. Okay, then the main library is Seaborn. So import Seaborn as SNS. Okay, so you can use any name as alias, but SNS is very standard and widely used, so that's why I'm using same name. Okay, so let's run it and load all the libraries. Okay, so all libraries are loaded. So after library is loaded, right, so there are two ways to get the data. Either you download from external website or using Google also. And instead of downloading from external data, you can use Seaborn library itself to load one of the toy data. Okay, so let's see what and all toy data set is provided by Seaborn. So under SNS, we have one function called get dataset. Okay, so let me see what is exact name. There is something called get dataset. Get dataset names. Okay, so what I'll do now. So let's see what and all datasets already available. So we have anagram, then enscombe, attention and brain network, car crashes, diamonds, dots, exercise, flights, fMRI, then gammas, geyser, iris. So there are a lot of data. Okay, so we may see a couple of them, but maybe for today's example, I may use a very small, and the best one is you can use Titanic as well, but Titanic I'm going to use it for case study, so I'm not going to show this data today. Rather, I'll use tips. Okay, so this tips data, what it does basically. So when people go to restaurant, right? So they have lunch or dinner, they do or smoking, non-smoker people will also be there, right? How much tip they are paying on top of whatever is the final bill, correct? So that kind of data is collected and put under tips data set. Okay. Similarly, we have iris data set. This is related to flower, petal length and sepal length and width, and their various species. Then we have something called MPG. This is automotive data. So different kind of what to say, car and their different kind of engines. It is 4-stroke engine, 3-stroke engine, like that we have. Okay, and when it was manufactured, and whether it is 2-tire or 3-tire, all those details are captured under MPG data. So I think after completing this video, you guys just go through each data and understand and just explore it. Okay, so as I mentioned, I'll be using tips. Okay, so let's see how to load the data of tips. So df equal to SNS. It is already maintained in the form of table data, so I can directly get the data frame. So we have load data set, and what is the name of data? That is nothing but tips. Just give the name. Okay, and df dot head 5. Okay, so we have total bill, tip, then gender, smoker, day, time, and size. Okay, so smoker is like whether they are smoking or non-smoking. Day means I think all 4 or 5 weekdays they have considered, like Monday, Tuesday, Sunday, and Saturday. And time is like lunch and dinner. And size is nothing but like people size. How many people went for dinner? How many people went for lunch? Okay, and how much total bill they paid. So this is just example data. And on top of total bill, how much tip they paid. Okay, and whether they were male or female. So these kind of data this is very good data set for playing with the data and do a lot of visualization around it. Okay, so our data is loaded now. Let's see a couple of other things which is provided by Seaborn. So in Matplotlib, we saw like it was just plotting 2D and in the white background, right? So there also you can control a different kind of background in Matplotlib, but here it is made easy. So let's see what and all styles are supported. So SNS dot, we have one function called set style. So if you are not sure about style, just give some random name. Okay, so just run it. So if you are giving some wrong name, it will show like what and all style will be supported. So we have white, dark, white grid, and dark grid. So let's talk about these 4 and we'll set it whenever it is needed. I'll just put it as comment, and I'm going to set right now, which is by default as white. Okay, so let it be white, and later we'll control it. Okay, so now we are set. We have data set and we have one background data also. Okay, so now let's see the first graph, that is count plot. So if you have seen bar plot in Matplotlib, right, what it does, it takes one particular category and how many counts of those values are there. That is kind of shown as in the bar plot. So same kind of thing can be done in Seaborn using count plot. So let's see the data now. So what I will do, head 2. So I'll be using this head 2 very frequently because as screen we are going down, right, we may get the data hidden. So I'll just get the idea like what and all features are there, columns are there. So let's see the count. So first we'll see like how many male and female were there, right? So what we can do, SNS dot count plot, and if you see help of any kind of plot, right, it has a lot of parameters supported. So what is your X data, what is your Y data, what is hue? This is the dimension I was talking. Okay, so hue is nothing but, let's say, your third variable. So X and Y data is plotted, right? Now based on some category, those XY data is different, basically Y data is different, right? So that hue can be taken as a third parameter or third dimension data. Okay, so accordingly all the data will be segregated and plotted based on those categories. Okay, so this data or parameter will be very helpful where you have a lot of categorical data in your data set. So let's go with just plot tf dot 6. Okay, you see here it is by default plotting male, female, and see it has automatically given X title and Y title also. Okay, so I think I have not shown in Matplotlib, but this is very important and very easily you can do that. So maybe what I'll do, I'll just show one example here. plt.plot bar plot, and here we have df dot okay, this is not the count, right? So what we can have here, df dot okay, so this is the way you can get total count, and you can just do the plotting using Pandas default plot. Okay, so plt, you can just give kind equal to bar. That's how we plotted, right? Let it come. Yeah, so if you plot like this, either using Matplotlib or Pandas default plot, it is just going to show the data, but it is not going to show the title, right? So explicitly you have to mention like plt dot x label. So I can give x label as, let's say, gender. Okay, so now gender is coming, right? Similarly, you can have y label as count, and you can give y, and here you can have plt dot title. This thing I have not shown, but I'm just showing you right away so that you can understand how this labeling is done. So title is nothing but gender count. Okay, so you are all set. You are giving x label, y label, as well as overall title of the graph. Okay, so same thing is being done here as well as in the Seaborn, but this is happening automatically. How? Because you are giving this particular data, right? So it is automatically fetching the category name of the data, and accordingly it is showing the data. But overall title is not present. So it doesn't mean like you are using Seaborn, you will not be able to set the title for the graph. You can still do that because, as I mentioned, it is written on top of Matplotlib. So all the graph axes and other thing will remain same. So plt dot title, I can mention gender count. Okay, so all remains same. So this is the way you do the count plot. Let's talk about bar plot. Okay, so again, I'll take df dot head to. So let's see what SNS bar plot does. See here, it is also having a lot of data. Okay, so I'm not going to play around all the parameter. Whenever it is required, we can play, but top most required data parameter we'll be using. So what it does, show point estimates and confidence interval as rectangular bars. Okay, so here I'll just take x equal. There are two ways to do that. So either you can use df dot, let's say, again, I want maybe smoker. Okay, so x-axis will be smoker and their count will be df dot, let's say I have total bill. Okay, so this is the first two parameter, right? X and Y. So if you are not mentioning using keyworded argument, that's fine. So by default, it will be taken as X. So let's mention it. So always mention whenever you already have keyworded argument. Okay, so it will be more readable. That is a good practice. Okay, so if you do this plotting, so with smoker, like whether it smokes or doesn't smoke, and what is their total count. Okay, so along with this, for those who are smoking, they are paying max 20 bill. Okay, bill amount is 20, and those who are non-smoking, they are playing very close to 20. Okay, that's what you see here. And in the bar plot, whatever you see, right, this particular line, this is nothing but your error line. So if you see here, By default it shows. If you don't want to show, you can just remove it. Okay, so here there's something called error color, right? So you can just remove it by controlling the width. So I don't want to show the width, so you can just make it none or 0. So we see here, error width is the float value, thickness of error, bar, lines, and caps. Okay, so let me just control in another graph. Yeah, so by default it is having some float value of that width. That's why it is shown here. If you make it 0, it will not be shown. Okay, so that's about bar plot. Now let's talk about adding more number of parameter in the same graph. Okay, so as I mentioned, the beauty of Seaborn is you can plot multi-dimensional data in 2D plot. Okay, so how to go with multi-dimension? So let's talk about, we have one parameter called hue, right? So hue is the parameter which will add the dimension or more dimension in the graph. Okay, so let's get what other categorical value we have. So under smoker, total bill, let's talk about those who are male or female, right? So what I'll do, under hue, I'll add df.6. Okay. So it will take the category of gender, that is male and female. For each category, it will plot your total bill as well as smoker, whether it is yes or no. So we have yes, smoker, yes, no. And those who smokes, we have male candidate more, female candidate less. Or basically the bill which is paid by male is more, and bill which is paid by female is little less than male. Okay, so that's what you can infer from this particular graph. Okay, so this is about adding hue or adding third dimension in the graph. Okay, so we'll see one more example, maybe under scatter plot, where we can add fourth dimension also. Now let's talk about line plot. So SNS dot line plot. So we have, let's say X, I want total bill, maybe that should be index, and Y value should be, so index basically for each value, right? So the first value, nothing but 0th index, and second value is first index, like that. And for each index, I want this, the total bill. This index I'm talking 0 and 1. Okay, and Y value should be, let's say df dot total bill. Okay, so let's see the line plot. Yeah, so that's how your, but it doesn't make any sense, but I'm just showing you how the line plot works and how you can plot it. Okay, so here it is very dense, so let's control the figure size. So now we have loaded plt dot figure. Under that we have fixed size equal to 16 by 4. Okay, so like that you can do the line plotting. So here you see automatically y label has been already put as total bill, because this is what we have provided. Okay, and index is not a label, so that's why you don't see any label here. If by chance, if you would have given some other category, numerical value graph detail, then it would have taken the X title also. Okay, so that's about line plot. We lot of details here. So again, here also hue parameters. Hue will be there almost all the plot of line. So let's see how this line is varying based on those who are, let's say we have df dot head 2. Okay, so let's add one more dimension here. So I want to see this kind of total bill trend for time wise. Okay, so those who are going for lunch and dinner. So hue parameter will be df dot time. Okay, so your one data will be lunch, one data will be for dinner. Okay, so that's how it is getting plotted. Okay, then we have some other parameter like line color, and you want to have dotted line now, which we have already seen in Matplotlib. So you guys can play with that and make more, or beautify your graphs. Next is histogram. Okay, so let's remove this one. So histogram, as I mentioned, it is nothing but it shows the value, how many times it is occurring, okay, or basically occurrence of the element, or how frequently or how many number of times that element is occurring from the data set. Okay, so df dot head to, so let's see, we plot. So where is the numerical value? We have, let's say, size, right? So sns dot hist plot df dot size. So object type number integer 64. What is this? Okay, maybe I can give y equal to, or maybe df equal to df, then y equal to total bill. Okay, and if I make it here, yeah. So here hist excuse me. So here in the hist plot, we are giving the data. So there are, as I mentioned, two ways to plot, right? Either you give the dot nation of data frame, or you directly give the data equal to your data frame, and x and y parameter, you can just give the column name of the data. Okay, so I want to see histogram of total bill. So if you see here, right, the bill amount which was frequently paid or more number of time it is paid, that is nothing but which is varying between, let's say, 20 or maybe 15 to 16. That's why you see the peak here, right? And out of total bill, it is occurring almost close to 48 times. Okay, that's what you infer from the histogram. Let's see what other parameter we have. So definitely we will be having hue parameter, because I can have a histogram plot for the male as well as female. Correct. So let's see. Yeah, we do have equal to, I will just give, so I'm not giving df dot sex. Why? Because I have already given data type as df. Correct. So now two histogram will be plotted for male and female. You see here, and automatically color will be controlled. So let's go with default color. Why? Because SNS in Seaborn library, they have already given those default color, which is widely accepted. Okay, so you don't have to really control it. Now let's see the next one, distribution plot. So SNS dot dist plot, what it is. So flexibly plot a univariate distribution of observation. Okay, so this is nothing but a kernel density estimation. Okay, which is kind of histogram plot, but it will just plot a line. Okay, so here what I want, df dot total bill. Yeah, so this is what we saw here, right, for the total bill. Okay, and this is internally by default, it does basically a estimation, kernel density estimation plot. What is KD? I will explain in the statistics. Okay, so under that graph, like how your data is distributed, that will also getting plotted here. Okay, so if you see, there's one parameter called hist or distribution, which will make it false or true. So hist is true here, right? If you are making hist equal to false, it is not going to plot this, because we have already plotted in the histogram. Correct. So in case you don't want, you just make it false. Okay, now next is, let's say, hue. So this time I would like to make hue as df dot day wise. So we have 4 days, right? So for each day it is going to plot. Got an unexpected. Okay, why it is not taking? Oh, it doesn't have a hue parameter. Okay. So do we have KD plot? Let me just check. Okay, it is there, right? So there we can play. And I'm going to give exactly same thing. Yeah, this will work. Okay, so let me use this KD plot, kernel density plot, kernel density estimation. Okay, so here this is nothing but exactly same as distribution plot, but here we have hue parameter, which is very important. Okay, so let's say you have a lot of categorical value and how your data is distributed across, between certain range. So with that, it will be very helpful, and you can easily visualize your data. Okay, so this will also help you to easily get like what is your mean, and what is your percentage of data out of total data or total population, how it is centered between the mean. Okay, and how many such values are there which is centered between the mean. Okay, so which you will get to know a little more once I explain the statistics. Okay, so that's how you do distribution plot as well as uh, kernel density estimation. Okay, so under distribution we have one more parameter called rug. Okay, so rug is nothing but if you just make it true, right? So it is going to show all the data just below the peak, okay, or just below the line, whatever is plotted in the distribution plot. And it is just show like how dense your values there. As I mentioned, more values are centered across this peak, right? So you see more density and how your data is dispersed around the tail of that distribution plot. Okay, so you can make that true, you can control the color as well. Okay, so that's about distribution plot and KD plot. Let's see the Ecdf plot. Ecdf is nothing but empirical cumulative distribution plot function. Okay, so what exactly it does, right? Whatever values you have, right, it will take all cumulative sum and it will just plot in the data in the graph. So we do have direct function for this SNS dot Ecdf plot. When you want to see something cumulative, then go with this df dot. Let's say I have total bill. Okay, so if you would have taken histogram, then it will plot in the bar graph, right? So there you may have to do some smoothing and all, but here it is not required. Internally it has been taken care, and that's how it is showing the cumulative bill. Okay, what else we have under this? Yeah, we have hue parameter also, so you can control the hue by adding another dimension. So let's say hue, I want to add df dot male and female. Why it is not taking again? Okay, so what I will do, I'll just, whenever you get this kind of problem, right? So better you give data equal to your df. Okay, and your x is nothing but total bill, or maybe df dot index, and y is nothing but total bill, and hue is your gender. So or not, or by where it is not plotted. Okay, then I can just either go with x or y. I'll go with y. Okay, so this is for male and female. You can see here proportion, how the proportion is distributed, right? So for male you have more, and for female it is little less. That's what you have exactly seen in the bar plot also. You see here in the total bill, for male it is more, female it is less. Okay, so there are various plotting. Whenever it is required, based on that you can take whichever you want for your project. Let's go with the scatter plot. So SNS dot, before that let me get data. Okay, so SNS dot scatter plot. Okay, so again it needs x, so x I'll give df dot index, and for each index I would like to have total bill, how it is distributed. So df dot total bill. Okay, that's good. Let's control the figure size. plt dot figure to 16 by 4. plt dot show. Okay, so scatter plot is plotted. Now let's add some more beautiful things about scatter. Okay, so now here I'll show how you can add 4-dimension data in your single 2D plot. Okay, so what other parameter we have? So index total will we have already given. So let's talk about male and female data, how it is distributed. Okay, so I'll give you parameter as df dot sex. Okay, so you can see automatically color coded will happen. So orange color is female and blue color is for female male. Okay, so that's how your data is distributed. So if you see right clearly, blue data is little more. Okay, and orange data is little less than blue one. So this is one dimension. Let's add another dimension here. Okay, so now this time I would like to add different markers also. So now 3-dimension added, 4-dimension I'll add. Markers will be, let's say, I want to control, we have something called day, right? Df day. So let's add another dimension, that is 4-dimension as a day. So so total 4 kind of day we have: Sunday, Monday, Tuesday, or Wednesday. Let's see. Okay. So for between these data set, right, which data is particularly for Monday or Sunday, Saturday, or Friday. Okay. So we have something called markers. Okay, let me take another one. So guys, remember we are going to add, or we are about to add 4-dimension in this 2D plot. Okay, so we have something called markers equal to, or maybe style I'll give equal to df dot day. Okay, you see here automatically Thursday, Friday, Saturday, Sunday is added. So index total will 2-dimension. 3rd-dimension is your gender, that is male and female, and 4th-dimension is how your data is distributed across Thursday, Friday, Saturday, and Sunday. Okay, so that is the beauty of Seaborn. So let me add here. Now let's add something more. So you would like to control this one. You would like to control the size, right? So size also I can give size equal to df dot team size. Let's go with that, whether it is able to add or not. I think it is able to add. Okay, only thing is factor is little small, so maybe I'll try to multiply by 20. No. Okay, it is taken some default size. Okay, no issue. I'm going to add now marker style, markers. So if you see by default, it is taking Thursday as circle, Friday as cross, Saturday as square, and Sunday as plus sign, right? So I can define my own markers equal to, so let's say I want to have big diamond and big hexagon. And let's say I want to have star and I want to have P. P is nothing but plus sign. Okay, so that also you can do. So accordingly, it will be taken and it will be showing all the data. So now you understand. I hope you like this particular graph and Seaborn library, and I suggest you start using it and keep applying this particular graphing library in your data. Okay. Now let's see the box plot. So box plot is very important whenever you talk about data analysis. Okay. And whenever you are going to do some kind of statistical analysis for data, this is one of the best plot and one of the first plot you will be using. Okay, so let's talk about df dot head to. So here we'll be using df dot box plot. So for box plot, I'm going to plot total bill. So df dot total bill. So unexpected, okay. It is just needing the data, or not df. It was correct. It should be Seaborn SNS. Okay, so this is your box plot. So how it works basically, you will be taking the full data, and the full data, how it is, what is the minimum value. So This is also known as whisker plot. Why? Because two whisk will be there. That is the min and the max. Okay. And in between min max, you have three quartiles, that is 25%. You see this below line of that box. Middle line is nothing but your median of data. So and above the median, you see the 75%. So median is your 50%. And above the median, it is your 75% data. Okay, so you can clearly tell around 25% data is my, or the bill value of 25 is nothing but falling under 75 percentile. Okay, so this is the best way to get 5-point summary also. So min, max, 25%, 50%, and 75% data, and all those belongs to outlier. So what is outlier also I'll show once I talk about it, statistics. Let's add some more parameters. So control the width first, because it's something which is required to add, because by default it is too wide. So I'll make it 2. Okay, now this looks good. So that's how you control the width of box plot. Now let's add hue parameter. Okay, so I would like to see how total bill is spread across various days. So I'll just use df plot day. Okay, so you see here, it is not taking. So x equal to df dot day. For each day, I want to have box plot. Okay, that's fine. Okay, so Thursday, Friday, Saturday, and Sunday. Okay, let's control the width also. Dot figure 16/4. Okay, looks better. Let's have 5. Much better. Okay, so for each day I got. Now for each graph, I would like to have, so now I'm going to add the 4th dimension. Okay, 2 dimensions I already added. 3rd dimension I'm going to add as hue parameter. I want to have between smoking data and non-smoking data. Okay, so df dot smoke. Is it smoker or non-smoker? Let me just check. Smoker. Okay, so now you see here, for each day I would like to get that box plot for smoking and non-smoking versus person. Okay, so that's how you add it. So by this time you would have realized how powerful is this Seaborn library. Okay guys, so that's about box plot. Now we have enhanced version of box plot, that is nothing but boxen plot, box enhanced plot. Okay, so what it does, it will just do the box plot, but the way your data is dispersed, right, accordingly that box will be plotted. Okay, so maybe I can just take same example and I'm just going to remove or add en, that is nothing but box and plot. Okay, now you see. Well, let's take one small one. So here, first let's talk about only width. Simple one. Okay, so how your data is dispersed, that is also is getting controlled along with the box and plot. Okay, so you'll see here, basically it will show more distribution. Earlier we were not seeing the distribution, right? It was just min max and your interquartile lines, right? But around min max and interquartile lines, how your data is dispersed, more quartile will be shown here. You see more number of quartiles. Okay, so anyway, this is, yeah, so these outliers, and around this, below this particular median line, right, you will have more number of quartiles. Okay, so that is what is your boxen plot. Let's see the swarm plot. So swarm plot is nothing but to draw data set on box plot. Okay, so if you just do the data plotting here, so here I'm going to take SNS dot, I'll just take the same example. Swarm plot, X is day and total bill. Let's talk about this. Okay, so basically it is exactly, if you just remove these lines and border of this particular graph and just put the data. That is what is your swarm plot. Okay, how your data is dispersed along the given data. Okay, so yeah, nothing much in this. You can have hue parameter here as well. Yeah, so hue is there. So let me add one more. df dot, let's talk about 6. Okay, yeah. So for each data, I will have male and female separate, how the data is dispersed. Okay, guys, so that's about swarm plot. And now let's talk about violin. So this is another, so these kind of plot, right? It's all works about whenever you want to see your how data is distributed, go with these plots: swarm plot, violin plot, your boxen plot, and box plot. Okay, and of course scatter plot is there. So I'll just use violin, just name the change the name. Okay, so here, if let me just show the basic one first. Okay, so if you see here, right, it is nothing but your combining your distribution plot as well as density estimation. Okay, and if you see here, the box plot is also plotted, and in the middle you see a white dot, right? That is nothing but pointing to the median of the data. Okay, and that's why you see where is your peak, that is your median. Okay, so from median, how does data disperse? Okay, so above the date, above the median, below the median, correct? So that's what is this. And now if you want to plot or modify a little more details, we have something called, let me just show you. Inner is box, right? So let's see what and all we have under inner. Let me give some name, so I'll get to know what and all is supported. Okay, it is not there, then I need to check the help. So we have not this one, violin plot. So under inner we have box, quartile, point, stick, and none. Okay, so by default it is none. So let's see what and all we can change. So inner is box, which is by default. Okay, all clear. Now let's talk about quartile. So what it is going to show now, it will show all the quartile data. You see here. So basically this is your median, and this is your 75 percentile, and this is your 25 percentile. So 25, 50, median is 50%, and above that 75%. Okay. Now let's see the next one. We have point. Whether you would like to show the point or not. So this is nothing but again your kind of scatter plot without any jitter. So jitter is nothing but it will just spread the data across the distribution. If you don't want to do jittering, then it will just plot in the single strip plot. And this is also known as strip plot basically. Okay, so yeah, that is about point. Now we have next one is stick. Okay, so it is going to plot the stick for each given data. Okay, so whichever works for you, probably you guys can use it based on the need. So that's about violin plot. Let's see the next plot. Used to plot data over categorical axis. Okay, so we have SNS dot. Let me take same example. So what is my categorical value? X, Y. So day wise, sorry. Strip plot. Okay, you see here. So how the data is spread across and for each day, because I'm giving Y as total bill and X is your day wise, correct? So that's how you can do. And if you see here, there is one parameter, interesting parameter about strip plot is nothing but jitter. So by default, jittering is true. If you make this jitter false, and you are going to get the data exactly the same what you did here, this middle line. Okay. So let's plot it again. I'm going to make jitter equal to false. Okay, so jitter equal to true only required whenever you want to see how your data is dispersed. Okay, from top to bottom, all the jitterness will be given. And you can see, like, basically just to avoid or just to showcase your all overlap data. Here a lot of data is overlapping, right? But you don't want to see that overlap data. Then you make jitter as true, which is by default true. Okay, and I think we will have hue parameter here as well. Yeah, so if you want to have hue as equal to df dot, let's say, over gender. But again, if you make here, yeah, see, everything is overlap, right? So in this case, you make it true. You'll see more clarity on that. Okay. Now, what else we can take? Any other categorical value we have? Let's see now. Smoker versus non-smoker. Yeah. Let's talk about smoker. Yes and no. Okay. So that's how you work with strip plot. Now let's talk about pair plot. So guys, pair plot is also very important, and this is going to be used heavily when you have a lot of numerical data uh, in your data set. Okay. So what it does is basically filter all the numerical columns and try to derive what is the relationship between those numerical data. Okay, so this is one of the best plot to find out the relationships between various features of your data. Okay, so if you see my data here, df dot head, so I have here total bill, tip, and I'm talking about only numerical because pair plot is going to take only numerical values. Okay, total bill, tip, as well as size. So we have one function called correlation, right? So I'll just store it under correlation variable, which is nothing but going to be a data frame. Okay, so df dot correlation, that is a function. So I'm going to just get it and just print it. So what it does, basically, it will just find the correlation between total bill versus total bill. So one same versus same will be always one. So it is highly correlated, right? So tip versus total bill, if you see, it is having positive correlation. Okay, so that is correlation factor is 0.67. Similarly, total bill versus size. So okay, so that is almost close to 60%. Okay, so once you get this right, it makes sense to plot data or using the pair plot over correlation. Okay, so what you can do now, SNS dot pair plot and just provide the correlation value. That's all. Now see the magic. Or without giving this also, you could have given the whole data frame. Anything is fine. So I'll show both. Let it run. Okay, so I think I should give actual data, not this one. This I'll take it for heat map. So what you can do now, df take this one here. Yeah, this makes sense. So what it does, basically, it is trying to find all the numerical values, that is nothing but a total bill, tip, and size. Okay, so total bill versus total bill, that will be like highly correlated. Okay, and total bill versus tip, you see, if you are increasing the total bill, your tip is also increasing. That's what you can infer from the data set, right? You see this x-axis, my total bill is increasing and tip is also increasing. Okay, similarly, you can see the size, total bill versus size, then tip versus total bill, that exactly you'll see. Okay, so basically either you can consider upper diagonal or lower diagonal, both will be same. Okay, so that's about pair plot. Let's talk about the heat map. So there is some limitation here. So if you see, all the diagonal graphs are nothing but histogram, and above and below the diagonal, it is nothing but scatter plot. So how you can do different kind of plotting below the graph below the diagonal or above the diagonal, or how you can change the diagonal graph property also. That we'll see under FacetGrid or PairGrid, which we'll see in the next Seaborn video. Okay, so when you want to have a quick glance of how your data is dispersed and how your numerical data looks like, pair plot is the best plot. Okay, now let's go to heat map. So heat map, I told, right, we will have confusion matrix in machine learning. So they are like true, false, and true versus false. Okay, or true, false for positive and negative values. Okay, so you will have kind of one 4x4, 3x3, one kind of square matrix, or any kind of rectangle matrix. Anything is fine. So once you have a lot of numerical data, so it is very hard to visualize, right? So their heat map will be showing clear relation between those values. Okay, so to plot heat map, I have just created a matrix here that is pure numerical value, okay, using correlation. And if you want to see or you want to visualize, right, we have something called SNS dot heat map of correlation. Okay. Yeah, so total bill versus total bill, tip versus tip, tip versus size, all those things data. So how they are correlated, basically those can be seen here. So the value which is like very light color will be highly correlated. Okay, so that's what total bill versus total bill. These same values, of course, it is highly correlated and value will be 1. Total bill versus tip, is it really correlated? No. If you see here, tip data is very dark, right? So what does it mean? Darker the data, lower the relationship, or less the relationship, or very less likely it is correlated. So this is the default plot of heat map. Now let's do some annotation, put some values here. We have something called annotate equal to true. So it is going to put all the correlated value against each row or column. Okay, so of course all the diagonal will be highly correlated because they are in the same value. So total bill versus total bill, correlation is 1, means highly correlated. Total bill versus tip, this is almost 68% correlated. Okay, so what exactly you can infer from this data? If your total bill is increasing, your tip will also increase. Of course, those who are paying more bill, they are giving more data, more tip, right? So higher the percent, tip will be more. Now let's say whether this is related or not, you can find out size versus total bill. Okay, so that is also close to 60% related, because more the size, more the bill, correct? Yeah, so that's how you understand the heat map, and you can plot the correlation between the numerical data. Okay guys, so I think, yeah, it is good enough for today, and I hope you like this particular concept under Seaborn. And I would suggest, please, start using it, because this is, from now on, you are going to use it very heavily, because after this I'm going to start exploratory data analysis. So we'll pick up any random data, do quickly visualization using Seaborn, understand what kind of data is there, and how to do the data cleaning. So all those things will be helpful when you are doing the plotting. Okay, and after cleaning the data, you can do better plotting. Okay guys, so that's all about this, and the remaining part I'll cover in the next video. So we'll see what is FacetGrid, what is KD plot, okay, and what are different variations on those plots. These are very important. Okay, what is joint plot, regression plot, PairGrid, and cluster plot. So that we'll see in the next video. Okay guys, that's all for today. I hope you like it. If you don't like, then please put your comment in comment box. And those who have not subscribed my channel, please do subscribe and get latest update on the videos. Thank you so much. Bye-bye. Hey guys, Pankaj here. Welcome back to my YouTube channel. In first part of Seaborn, we saw all the basics of Seaborn plot, right? And today we are going to see a couple of advanced functions. So let me show you all the details. Yeah, so in this video, we are going to learn about FacetGrid, okay, then KD plot and a couple of its variation. What is univariate plot? What is bivariate plot? We'll see joint plot also, then regression plot, and PairGrid plot. This is advanced version of pair plot, okay? And finally, we'll see cluster map plot. Okay, so let me import all the basic libraries, that is NumPy, Panda, Matplotlib, then Seaborn, and this last one I can remove. Okay, then let's set the style. So last time we saw style as white, right? That is by default. Today we are going to set as dark red. Okay, so basically it will be in the plotted area, you will have lines and a little gray area of background. Okay, now I'm going to load some data sets. So SNS dot get data set names. Okay, so we have a lot of data sets. So we had used tips in first video. So let's use tips only. Okay, so df dot SNS. Remember guys, while loading data set, make sure that you have internet connection, okay? Because first time it is going to download from internet. Data set tips tip dot head 2. Okay, so again I'll explain about this data set. Though for those who are watching this video first time, please see the first part, then you come back. Okay, so we have total tip, total bill, then total tip given by that, then gender, male, female, smoker, like yes and no, and day we have 4 different days, and lunch time and dinner time, and size of the team who went for lunch or dinner. Okay, so first one is FacetGrid. Okay, so guys, if you saw a pair plot, right, it was taking all the numerical columns and just plotting the data, okay, with like diagonal as histogram, and rest was the scatter plot. But in FacetGrid, you can control number of rows and column based on the category given, okay, and later you can map like what particular plot you want. So in this function, FacetGrid function, it is going to create a object. So let's give object name as fg, then sns dot FacetGrid. Now it will take the data. So my data is df, and how many rows you want. So I want total number of rows to be created based on total number of unique values in day. So let's give day as parameter, and how many column you want. So column will be, let's say, total time wise, lunch and dinner. Okay, so once you see fg created, you will see empty plotting will be created, empty plotted area where number of rows and column will be divided into different subplots. Okay, so you see here total 4 days and total 2 columns based on time. So once you have fg fg object created, then you can do the mapping. So mapping, what it needs a function. So I want to plot the data of SNS dot, let's say, scatter plot, and what should be my x value and what should be my y value. Okay, so let's say I want to have x value as df dot tip and y value as df dot total bill. Okay, so why this error? None of index. Okay, so index, let me give df dot index. Size scatter plot. Why is it not taking? My mistake, because I have already given data set name as df, right? So here you need to define that. Let me go back to the first one, tip. So it has to be passed as string, not as the series. Okay, so your x will be tip and y will be your total bill. Okay, so you see here all the scatter plot has been plotted, right? Okay, for some data it is not there, like so for Sunday we don't have any data, and for this also we don't have any data, that's why you don't see any data. Okay, so later if you want to plot, let's say, gender wise, right? So number of gender, I want this, and column should be, let's say, I will put as day. For male female day wise, I want to have tip versus total bill. Let's plot this one. Okay, so this is number of rows and column. This looks better for understanding. And now I want to control third parameter. Okay, to add third dimension, we have something called hue. So what should be my hue parameter? Let's give hue as time. Time should be okay, whether it was lunch or dinner. So now you will see different color also will be coded here. So the beauty of FacetGrid, if you are comparing with PairPlot, because number of rows and column, once you are not sure how many to be given, then go with the category. So based on number of category, it will automatically create number of rows and columns. Okay, so let it come. Yeah. So in some part, you see only male part has been contributed for total bill. And in some days, male and female both are there, right? And let's talk about Friday. And here Thursday looks like only male. This only for only Thursday you see male, sorry, female candidate. Sorry, this is male candidate. Okay, and here we have. Let me add legend also. We dot add legend. Yeah, so this legend is nothing but for lunch, or basically time we have given, right? So lunch and dinner. Okay, so you see, looks like Thursday only male is going for lunch. Okay, they did not go for dinner. Okay, and here if you see lunch and dinner both are there for female only on Friday. And here if you see in this particular graph, Sunday only male candidate went for dinner. There was no male, correct? Sorry, there was no lunch. So this kind of data you can definitely conclude by seeing the graph. Okay, so that's about FacetGrid. So as I mentioned, it is useful only when you're not sure how many rows and column to be given. Go with the categorical total number of unique values. It will create the row and column respectively. Let's see the KD plot. So under KD plot, as I mentioned, this is kernel density plot, how your data is distributed from the mean or from the peak value. Okay, so here we have two kind of plot. Let me just add UFED. We have univariate plot, means single variable if you are plotting, and bivariate means two variable you are plotting. Okay, so let's plot the single variable. SNS dot KD plot. I want to plot, let's say, total bill. So I'll give Y so that you can see around the x-axis. Df dot total bill. Okay, let's give x not y. Okay, that is univariate, and here you can add hue parameter also. So hue, let's say you add df dot gender. Similarly, you can have df dot, let's say, day wise, 4 days. So all 4 different data will be created. So this is all your univariate data. Okay, now when we have something called bivariate. So x versus, you can plot the data. So whenever you plot bivariate, it will be showing as a contour plot. Okay, so contour plot, as I mentioned in the previous video also, is nothing but mostly it is used for geographical data plotting. Okay, so for, let's say you have hill or mountain, right? From the peak, how your data is dispersed till the bottom of the graph. Okay, so if you plot a circle on the top, then below circle and on top from equidistance, how your data will look like, that's what will be shown in the 2D plane. So let's plot it under bivariate. Okay, so bivariate you need to have x-axis. So x I'll give, let's say, tip versus total bill. Okay, and hue I'll add it later. Let's go with that. Okay, so this is what I told. This is your peak, and from peak data, how I'm telling this is peak, because if you see your data, right, this is your peak. From this peak particular value, so peak you see around, this is around 10 to 20, right? And that's what you see. This peak is nothing but around 10 to 20. From this peak, how other data is distributed, okay, till the bottom. So let's say you put a camera or put your eye on the top. From top, you are seeing this mountain. Okay, so peak will be at the center. From this, how your other data is spread across till bottom, right? That's what is shown in the form of contour. Okay, so this is your total bill. And in case you want to add hue also, let's say I add df dot 6. So based on male and female, this contour data will be plotted. Okay, so this is bivariate. Now you would like to add a couple of variation. Let's say we have something called shadow. This will be kind of filled. Let's see this value is correct or not. We have shade, not shadow. Okay, so your data will be filled. What other parameter we can change? So other than shade, we have vertical, kernel, different kernel sizes also you can give. Okay, cut, clip, legend. If you want to make true, you can make it. I think it is already giving, right? So by default it is true. What else you can provide? Color bar, if you want to C bar, you can provide, correct? C bar is nothing but your color bar. So darker or based on lighter value, it will show where is my data. So let's see what it shows. Okay, so since we have added two variable, right, male and female, for both that it will show the color. Okay, so sometimes this projection is also very helpful. Okay guys, so this is about bivariate KD plot. Now let's see the joint plot. So guys, joint plot is nothing but it is combination of two plots. Okay, so let's say you are plotting scatter x versus y, right? So for x data, whatever is there, it will be plotting on top of another x-axis as a histogram. For similarly y-axis, other side of y-axis, it will plot the histogram. Okay, so basically using single function, you can plot three different graphs. So let me get all the values. So we have SNS dot joint plot. So what and all it needs? XY, right? So X, I'll give df dot, let's say tip, and df y equal to df dot total bill. Okay. So you see here, if you just remove this, earlier we were seeing this is scatter plot, right? Now how your tip data is variated. So what is the histogram plot of this? That's what you saw, right? So if you plot SNS dot plot df dot tip, let's plot the tip first so that you can visualize the data. Exactly, this data is nothing but this one separately if you're plotting. Okay, similarly total bill, and that is what you see in the right side. This particular graph is nothing but this graph. Okay, so in case you have to plot separately, you have to plot three different separate plot, right? So rather doing that, you just plot the joint plot, so automatically data will be shown. Let's see a couple of variations here. So what other variation you can do? You can plot different kind of kinds also, right? So by default kind is scatter. We have some other plot. So let's see here. So kind is nothing but scatter, KD hist, and this one. Okay, so let's plot this. I'll go kind with, by default it is scatter. Let's plot kind equal to KD. Next we'll go hist. Okay, so this is your KD plot, and this is going to be your hist plot. Now, so this is like two variables are plotted, right? That's why you see digital kind of information, but this is like data is getting ordered. That's why you see that. Now, next we have hex plot. So whichever way you want, right? You can project the data. Okay. So this is your hex plot. Then we have something called regression plot. So regression is also important sometimes when you want to see how your data is progressing, whether it is going down as your x-axis increases, whether it is going up, whether when your x-axis is increasing. Okay, so that kind of regression plot you can also plot. Similarly, you can control the color. So we can have color equal to, let's say, red. Okay, so individual color also you can plot, but yeah, it will be little more complicated, a lot of dictionary parameter into it. But yeah, this is good enough for default. Okay, so that's about joint plot. Now let's see the next one, regression plot. So regression is nothing but whatever you are plotting here, right? Same kind of thing you can plot separately also. So df dot head to sns dot reg, that is regression, then plot. So what it needs x-axis and y-axis, right? So let's say df dot index, df dot total bill. So as my data is increasing, what is the value of total bill? Okay, or it will make more sense if you are plotting tip versus total bill. So when, or total bill versus tip. So when your total bill is increasing, whether tip is increasing or in decreasing. So that kind of regression, if you plot, you will understand the relation basically. Okay, so you see the relation as your tip is increasing, total bill is also increasing, or as your total bill is increasing, your tip is also increasing. That's what is your regression plot. Okay, couple of variations we have. We have something called okay. So what we have here, log x, right? Log x2 if you make, then exactly the curved line will be plotted, exact relation. Okay, right now you see the straight line, then you will see little variation. So this log x2 will be very helpful when you have like parabolic equation, or maybe little quadratic equation with cube 2, sorry, root power of 2, power of 3 or something like that, right? So then if you make log x2, then it will show exact variation. Okay, so what else we have here? We have scatter. If you don't want, then make it false. Then I think this should be good enough. X jitter and Y jitter. So if you see a lot of overlapping data, right, then you can make X jitter and Y jitter as true. X jitter equal to true. Similarly, Y underscore jitter equal to true. Okay, so you will see, you will not see more data. You see a lot of things are overlapping, right? But the moment you make it true, it will be little dispersed. Okay, and of course you can add color also. Color equal to, let's say, magenta. So guys, whenever you are plotting any plot, right, I would say just go through each parameter and just play around. Then only you will understand. If you play around, right, it will be very helpful to understand how exactly this works. Okay, so that's about regression plot. Okay, now next is PairGrid. So let me talk about this, why PairGrid is required, and what is the difference between pair plot, FacetGrid, and PairGrid. Okay, so basic we started with pair plot. What it was doing, it was taking all the numerical column from the data set and plotting the data with histogram as diagonal, and below histogram, sorry, below diagonal and above diagonal, it was plotting the scatter plot. Okay, then we came back to FacetGrid. In FacetGrid, we were calculating row, and we were basically dividing the whole graph based on the number of rows and column based on number of unique values in the category. Okay, but there also we were not able to control how my diagonal and below diagonal and above diagonal graph should look like. So now PairGrid comes into picture. Okay, so this PairGrid, you will have, of course, all the numerical values, and of course hue parameter will be there that you can use for third dimension. Okay, but the beauty of this graph or this particular function is below the diagonal you can have whatever graph type you want. Above the diagonal, whatever graph type you want, you can control them separately. Okay, so let's see how it works. So this function will also going to create one object. So I will just mention pg equal to sns dot PairGrid Okay, let's see what and all it needs. It needs data. So this is my data. And any other parameter we have? Of course, we can take hue, palette, all those things, correct? So hue I'll show later. So let's plot this and PG. So automatically it will take all the data which is having only numerical values. Let me show what all numerical value we have. Let it plot. Yeah, so of course it will have three different numerical value. That's why 3 by 3 plot will be there. Total 9 graph. Okay, so how those 3 graphs are coming? It is because of this. So let it come. Df dot head. Yeah, so if you see here, total this total bill, tip as well as size. So only these 3 numerical columns are there. That's why you see 3 graph. Now once object PairGrid object is created, then you can control the graph. What graph you want in the diagonal, what graph you want in the lower diagonal and upper diagonal. Okay, so we have pg dot map dag. Okay, so what function you want? SNS dot, let's say I want hist plot. Okay, let's give that. So I'm just going to map only diagonal part. Let's see what it does. So Seaborn access grid, PairGrid at this location. So let it come. Okay, so you see only diagonal part I mapped, so that's why we saw histogram. Now let's map other part also. So one is for lower diagonal, one is for upper diagonal. So map I'll give lower, nothing but below the diagonal. Okay, and map upper, that is nothing but upper diagonal. So upper diagonal I want, let's say, I don't know joint plot will take or not, but let's give that joint plot. And below I want KD plot. Let's see if it takes or not. So meanwhile, let it come. And after that, I'll put some hue parameter also. Okay. So hue will be, let's say, I'll give the gender. Okay. So based on gender, male and female, it will do some color coding for each data. So let it come first. I think it is taking. But joint plot will have 3 different graph, right? In single graph. Let's see it plots or not. I think it is not able to draw it, but that's okay. So above the diagonal, that's why it is not taken. Lower part is not working, right? So what I will do, I'll just take, let's say, scatter, or maybe other than scatter, can I take bar plot, tip versus total bill? What else I can take? KD we have already taken. Let's take distribution plot. I think for distribution, got an unexpected keyword. Okay, I think it doesn't need. So what I can do, I can take maybe line plot should be okay, or regression plot. Let's plot regression. But numerical values are there, right? That will make more sense to have regression plot. Okay, let it come. So this will work. Yeah, this makes sense. So diagonal we have histogram, below diagonal we have regression plot, and above diagonal we have contour plot. Okay, so yeah, that's how you guys can manipulate the pair grid plot. Whatever choice of data you want and whatever choice of plot you want, you can just control it by mapping it. Okay, lower, upper, and diagonal. Okay, so that's all about pair grid. Now, in case you are going to add gender also, right, or maybe another variable, right, so you can have this. So you can control the hue parameter by providing this particular parameter value. And now you see, so whatever graphs have been plotted, now you can see the color code and segregate the data. Okay, guys, so that's about PairGrid. Now let's see the cluster map. First, let's understand what is the cluster map. So if you remember, I talked about grouping, right, in data frame. So what is grouping basically? So let's say you have a lot of data, a lot of categories, right? So for each category, you want to segregate the data for that particular unique value. Okay, so let's say you have gender, male and female. For male, what is my data set? For female, what is my data set? Okay, so that kind of grouping you want. So you would have heard about pivot table also, right? So in pivot table, what we do? We do this kind of grouping and filter the data according to each category. So that's what we are going to do here. So first I'll show how to create that pivot table. So tf dot head to I'll mention. So pivot table, I think it will work better when you have a lot of category, right? So let's say I want to have a row index based on the day. Okay, so tf dot pivot table. So it needs a couple of values, like what is your index level, what is your column level, and what values you want. Okay, so my index, I want tf dot, let's say day, 4 days. Okay, and columns, I want, I think it is call or column. Let's see that. Columns equal to df dot, let's say column should be time. Okay, so lunch and dinner, or maybe, yeah, this should be okay. And yeah, what is your values? So values, like which particular values you want. So I'm going to give values equal to, should be in the form of list. So I'll give total bill. Df this total bill. Okay. So for total bill for each day, what is my lunch and dinner? And this value is coming from where? This value is coming from this particular aggregate function. So I have given by default it is mean. Okay, so this may not work because for Saturday Sunday no such data available. That's why it is giving NaN. So take some other values. So let's say I'll give instead of day, or instead of lunch and dinner, I'll give smoker. Okay, for smoker, yeah, we do have data for lunch and dinner. Okay, now let's go ahead and plot the data. So for plotting, okay, the moment you create DFCs, I'll give df pivot table. This is my variable dfp. Okay, when you have table, then you just go ahead sns dot cluster map and provide your data as dfp. Okay, so it is going to create a cluster grid with your these categories: smoker, yes, no, and total bill for lunch and dinner. Okay, so by default figure size is too big, so what I will do, I'll just create fixed size equal to 5 by 5 and give values also. So annotate equal to true. Yeah, this makes more sense. And let's have some different values now. So I have given a smoker, and let's say column, can I give size? No, it needs category, right? So here, yeah, for this also we have a lot of values. And for total bill, I'll give tip also. So you can give multiple values. Okay, so for each category it is going to, for each column it is going to segregate the data. Okay, you see here for tip, what is my value for smoker, non-smoker, for Thursday, Friday, Saturday, Sunday. Similarly for total bill also. Okay. So now if you do the cluster mapping, you will see a lot of linkage of those values. Okay. Yeah, I think this is much better. And color bar is also provided. You can just do the controlling. What else we can do? We do have C map. I think it is not taking, or it does take, but let's pick it from here. Yeah, I think it has. So various color map also you can choose based on whatever list it has given. Okay. So that's all about cluster map. I think this will be very helpful. We have a lot of relation between different categories. Okay. So cluster map will be very helpful to plot and visualize the data. Okay, guys. So here it comes to end of Seaborn library. And I hope you understood a lot of plotting, and now you can create a lot of great visualization of your data. Okay, whenever you do exploratory data analysis, I believe with the help of Matplotlib and Seaborn, you can do great visualization. Okay, so that's all for today. And my next video will be based on natural language processing. So rather starting ET, I will start with natural language processing first, because we have to deal with, so far we have dealt with a lot of numerical as well as some string format data, right? But now we are going to deal with only the text data, which is very much unstructured data. And we'll do a lot of data cleaning, then, and then finally we will have clean data. And after clean data, what kind of data analysis we can do on top of it. So that part also you guys should learn. Then we'll go with EDA part for different projects. Okay, guys, and if you have not understood some part of Matplotlib or Seaborn, please leave out your comment in the comment box. And please do like and subscribe my channels. Thank you so much, guys. Bye-bye.